Today we will make an NFT marketplace. We can create our NFTs, sell NFTs, put them up for auction and like them. We will also be able to transfer money to our friends and edit our user. Also edit NFTs and receive notifications when a new auction is created, or money has arrived, or when our NFT is liked. We will use a Mongo database for the backend, Redis for caching, Docker for containerization, and Postman for testing. Also in the frontend part, such technologies as React, TypeScript, Axios, HookForm, React Context, React Router, and all that will be used. Well, let's get started creating the backend and then the frontend. Okay, let's move on to create our backend part. We need to create a folder called NFT Marketplace Dude, where our project will be. We need to open it in VS Code. Let's go. Now let's create a folder for our backend. We need to go into this folder and run npm init-y. Okay, now in the repository take this code where we simply install our dependencies. Oops, a little bit wrong. Let's wait. Copy, paste. Okay, let's wait until everything installs. Oh, everything is installed and we can move on. Let's install Node.js and ESLint. 1 second. Oh, oops, a little bit wrong. Oh. Fake install. Okay, npm install. Let's copy and paste. Okay, 1 second. Everything is installed and that's great. Okay, let's create a folder called src where all our main code will be. Let's go into it and create the rest of the folders and files. You can also copy all this from the repository. Mkdir, controllers, services. We need models, routes, middleware. And config, and the last one, utils. Okay. Now all that's left is to create our server.js, where our server will be. And that's it. We've created the backend folder, installed dependencies, created the src folder, and added all the other folders and files we need. Okay, we have a plan that we will follow. We've already completed the first step of this plan. We created a project, installed all the dependencies, and set up the project structure. Now let's move on to the next stage of the project. Let's go. Okay, and the next stage in our project is setting up our server. We will need to write everything in our server.js. Yeah, let's get started with this. Let's get started with writing our server in server.js. We need to import Express from Express, but to use import we need to change type to model in package.json. Yeah, now we can use import. Let's go. Next let's create our Express app. Yeah, we also need to specify the port where our server will be accessible, and it will be port 4889. Finally, let's add up listen and our port. We'll write the full path in console log, and when our server starts it will show up in the terminal http localhost and our port. Okay, a port. Yeah, that's it. Let's continue and import .env from .env. We need this so that we can read .env files. We need .env config. Now let's set it up so we can work with the JSON format. App use express JSON. This is necessary for parsing JSON data. Okay, let's create a route with a get request to the root path. Request response. Okay, if the server is working correctly, we should see let's hello from API when we access this path. Okay, let's try. Okay, we need to add a command in package.json to start our server node-mon server.js in scripts. Let's run it and specify the path in Postman. Okay, npm run server. Okay. we will test all our routes in Postman. Okay, as you can see, everything is working correctly. Let's try again. Okay, our server is set up properly. Nice. Let's process with connecting our database. We need to create our database in Mongo Atlas, connect to its browser code, and create .env file with our Mongo URL. Okay, go to MongoDB Atlas now and create a new project. Let's name it NFT database and click next. Here simply click create project. Okay, now click create a cluster and process to set up our cluster. Choose the free version and name it. Let's name it maybe Marketplace. Yeah. Next we will create an owner who will have access to our database. Copy the credentials and move on to selecting to the connection method. Yes, drivers. Okay, this will take some time and I will get back to you once I have the connection URL. And here is our MongoDB URL, but first we need to install MongoDB. Let's go to VS Code and install MongoDB. We need to navigate to our backend folder, and now we can simply paste this command and install everything. Okay. For now, let's copy our URL. Let's go to MongoDB, copy our URL, and click done. Here and check if everything has been installed. Okay, now we need to create a .env file and paste our MongoDB URL there so we can connect to it. Okay, let's define Mongo URI. Okay, let's save all. Okay, let's create a db.js file in the config folder. First, before connection, we need to allow connections from any IP address. Yeah, allow access from anywhere and confirm. This will take some time, and after that we can process with the connection. Yeah, pending. Okay, move to VS Code. We need to import Mongoose and .env. Yeah, Mongoose from Mongoose, and let's import .env from .env. Then we will call .env.config to enable access to the .env file. Next let's Next, let's create an async function named ConnectDB, which will handle the database connection. Yeah, ConnectDB async. We will use a try catch block. Yeah. Inside try, we will create a constant con to store the connection to our database. We will retrieve MongoDB from .env. Yeah, process.env MongoDB from .env. Let's check. Yeah, MongoDB. Okay. If the connection is successful, we will log a message displaying the MongoDB server address. MongoDB connected, and okay, con dot connection dot host. If there is an error, we will log it into console, and okay, error message, and exit the process using process dot exit one. Yeah. Now let's save everything and go to server.js. We need to add our database connection. We need to import ConnectDB from db.js. Okay. We will connect to the database when starting the server. Okay. ConnectDB. Let's save everything and test it. Save all. Oh, we forgot to specify the .js extension. Let's fix that and save again, and now everything should work. Yep. Let's save all. Okay, let's move on to the next stage of our development. Now we need to create 3 database model schemas: financial schema, NFT schema, and user schema. We will be creating many modules, but it will be worth it. Let's get started right now. Let's go. Yeah, now we need to create all 3 schemas in the models folder. We need financial schema. Next we need NFT schema. Let's create folder NFT schema. And the last, we need user schema. Let's create new folder, user schema. Let's move to financial schema. In financial schema, we need to create 2 models. First, transaction dot model.js. Second, wallet dot model.js. Okay, let's create new file, wallet dot model.js. Okay, now let's move on to the NFT schema models. Here we need to create auction model.js. Next, collection dot model.js, and the last NFT. Okay, let's create NFT dot model.js. Next, let's process to user schema and create the following models. First, auth response dot model.js. Next, follow. Let's create follow dot model.js. And the last, user. Let's create user.model.js. That's it. All our models are created, and we can now start filling them with data. Let's start with user model. First, we need to import Mongoose, which is an ODM, Object Data Modeling library for MongoDB. It helps us define schemas and interact with the database easily. Let's add this line to our code. Now let's define our user schema using Mongoose, mongoose.schema. A schema is like a blueprint that tells MongoDB what data each document in the user's collection should have. Next, let's create a username. This field stores the user's name. It's a string, type string. Required. Okay, required true, and must be unique. Yeah, same as the username. We need to create email, but it stores the user's email. Type string, required true, unique true. Yes. Let's create password. This field stores the user's password, which will later be encrypted. Next, let's create profile image. A string field to store the URL of the user's profile image. Next, let's create date of birth. Here we store the user's birth date and the data they joined. The date joined field defaults to the current date. Let's create date joined, type date, and default date now. Oops, date dot now. Okay, now let's define fields that reference other collections and store arrays. NFT likes. This array keeps track of NFTs liked by the user. Each like stores the NFT ID and the timestamp when it was liked. NFT type mongoose schema dot types dot object ID reference NFT. Yeah, NFT. Timestamp. Let's add timestamp. We want to check when it was liked, the NFT. Yeah, default date dot now. Let's create a wallet. Let's create wallet transfers. Yeah. This stores records of transactions made by the user, including the amount and timestamps. Okay, let's create amount, type number, and required true. Required true, yeah. Next we need timestamp. Type date and default we need copy, yeah. Okay, and the last auction bids. This tracks the user's bids in actions, storing the action ID, bid amount, and timestamp. Let's rename action bids. Okay. Type. We need type mongoose dot schema dot types dot object ID, and we need reference auction. And we need bid amount. Let's create bid amount. Bid amount with type number. With type number and required true. Okay. The next. Now that we've defined our schema, we need to create a model from it using mongoose.model. This model allows us to interact with the user's collection in MongoDB. Yeah, user schema. Finally, we export our model so we can use it in the other parts of our application. Okay, and here we have made user model. Let's create follow model.js. First we need to import mongoose. Let's import mongoose from mongoose. Now let's define our follow schema using mongoose.schema. This schema will allow us to track relationships between users. Next, we define the fields that will store information about the follow relationship. Follower. This field stores the ID of the user who is following someone. It references the user collection and is required. Let's define type. object ID reference user and required true. The next we need followed. This field stores the ID of the user who is being followed. It also references the user collection and is required. Okay, next date followed. This field records the timestamp of when the follow action occurred. It defaults to the current date. Let's create type date and default date dot now. Okay. Now that we've defined our schema, we need to create a model from it using mongoose.model. This model allows us to interact with the follows collection in MongoDB also. Let's follow schema. Finally, we need to export our model so we can use it in other parts of our application. Okay, and that's it. Next, we need to create our response model. Also, we need to import mongoose. Let's define our out response schema using mongoose.schema. This schema will store authentication response details such as tokens and associated users. Okay. Next, we define the fields required for our authentication response. We need token. This field stores the authentication token as a string. It is required to ensure that every response has a valid token. Next, we need to use user. This field stores the reference to the authentication user. It links to the user collection using mongoose schema that types that object ID, ensuring that each token is associated with a valid user. Okay, reference user and required true. Okay, required true. Yeah. Once our schema is ready, we use mongoose.model to create the auth response model, allowing us to interact with authentication responses in the database. Mongoose.model auth response and auth response schema. Yeah. Okay, finally we need to export our model. Let's export default auth response. And that's it. Okay, next we need to create an NFT model. You know what we need import. We need to import mongoose. Let's import mongoose. Now let's define our NFT schema using mongoose.schema. This schema will store details about NFTs, such as their name, description, price, and more. Let's define the fields. necessary for our NFT model. First, we need to create name. This field stores the name of the NFT. It is required string. Oops, required true. Next, we need to create description with type string. This optional field provides a brief description of the NFT. Type string, yeah. Next, we need to create price with type number and required true. This field stores the price of the NFT. It is required and with type number required true. Okay, we need to create auction and time with type date and also required true. This field records the end time for an action if the NFT is being actioned. It is required true, yeah. Next, create likes. This field stores an array of user IDs. Yeah, we need to create type mongoose .schema .types object ID with reference user. It references the user model and stores an array of user IDs who have liked the NFT. Yeah. Reference user. Next, we need creator. This field stores the ID of the user who created the NFT. We need to create type mongoose mongoose.schema types and object ID with reference user and required true. Yeah, it is required and references the user model. Required true. Yeah. The next collection with type also type mongoose schema types object ID, but the reference is collection. This field likes the NFT to a collection. It references the collection model. It's types object ID. Let's create references collection. Yeah, we need reference collection. The next, we need image with type string. This optional field stores the image URL or path of the NFT. Once our schema is ready, we use mongoose.model to create the NFT model. Let's create mongoose.model and let's create an NFT, but yeah, NFT, and use NFT schema. Finally, let's rename. We need to export our model. Export default NFT. And that's it. We've successfully created an NFT model. Next we need to create collection model.js. Also import mongoose from mongoose. Let's define our collection schema using mongoose.schema. This schema will store information about collections, such as their name, description, creator, associated NFTs, and creation date. Let's define the fields necessary for our collection model. First name with type string and required true. This field stores the name of the collection. It is a required string. Next, description. This optional field provides a brief description of the collection with type string. Yeah, type string. The next we need creator. This field stores the ID of the user who created the collection. It is required and references the user model. Yeah. Let's schema dot types types dot object ID, and reference is user and required true. Next we need NFTs. This field stores an array of NFT IDs that belong to this collection. It references the NFT model. We need to create type mongoose that schema that types that object ID with references NFT. Let's types that object ID with reference NFT. Oops, NFT. Right. Let's create date created. Let's create date created. This field records the date when the collection was created. By default, it stores the current date and time. Type date default date that now. Yeah. Once our schema is ready, we use mongoose.model to create the collection model. Let's create const collection mongoose.model collection, and we use our collection schema. Let's export our model. Export default collection, and yes, collection. That's it. Next, auction model.js. Let's import mongoose. Let's define our auction schema using mongoose.schema. This schema will store auction details, including the NFT being auctioned, the starting price, the highest bid, the auction's end time, and the list of bids. Let's define the necessary fields for our auction model. First, NFT. This field stores the ID of the NFT being auctioned. It is required and references the NFT model. Types that object ID and reference NFT and required true. Yeah, required true. The next starting price with type number. Yeah, with type number and required true. This field sets the minimum price for bidding. It is required and must be a number. Required true. Let's create a current bid with type number, and by the default is 0. This field tracks the highest bid in the auction. Yeah, type number, and by the default is 0. Let's create end time, and time with type date and require true. This field specifies when the auction ends. Yeah, it is required and must be a valid date. Let's create bids. This field stores an array of bid objects, where each bid contains the following properties. Bidder, the user who placed the bid. Yeah. Type mongoose that schema that types, and that object ID with reference user. Let's create reference and user. We need to create amount. Let's create amount. Amount is a bit amount which is required. Amount with type number and required true. Required true. The next we need date bid. The date when the bid was placed, defaulting to the current time. Type date. By the default it's date dot now. Once our schema is ready, we use mongoose.model. Let's create auction model. Const auction mongoose that model, and we use our action schema. Yeah. Finally, let's export our model. Export default auction. And we've successfully created an auction model. Yeah, that's it. Okay, let's move in financial schema in wallet model.js and import mongoose. Let's define our wallet schema. The schema represents the structure of our wallet document in MongoDB. Let's create new mongoose.schema. We need to create a user field is a reference to the user collection. It's an object ID and it's required and unique. Let's types dot object ID reference. We need reference user required true and unique also is true. Yeah, unique is also true. Let's check. Mongoose that schema that types that object ID reference user required true unique true. Yeah, right. Next we need wallet ID. Is a string that needs to be unique. Let's create type string required true and unique true. Unique true. We use a function generate unique wallet ID to generate a unique ID for each wallet. Yeah, default and generate unique wallet ID. In generate unique wallet ID, okay, we need balance. Yeah, the balance field is a number and it defaults to 100, meaning every new wallet will start with a balance of 100. The currency field is string and its default is Bitcoin. Yeah, when type string and by the default is Bitcoin. Lastly, we enable timestamps. Timestamps true to automatically add created and updated timestamps to the document. Yeah, let's create timestamps true. Let's create function generate unique wallet ID. We define a helper function generate unique wallet ID. This function generates a random string in base 36. Yeah, return. Check the repository and copy this line. Okay, yeah. The string in base 36 removes the leading 0 and returns a string like wallet ABC 123 and blah 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 as a unique ID for each wallet. This ensures that each wallet gets a unique identifier when created. Let's create a wallet model mongoose.model. yeah, wallet, and we use wallet schema. Let's export the wallet. Export default wallet, and that's it. Yeah. And the last, we need to create transaction model, JS, import Mongoose from Mongoose. Let's define the schema, transaction schema, which represents the structure of the transaction documents in our database. Here's what each field means. Sender wallet ID is the ID of the wallet. Yeah, let's create sender wallet ID. Is the ID of the wallet sending the money. It's a required string. Yeah. Type string, and it is required true. Next, we need a receiver wallet ID. Is the ID of the wallet receiving the money. It's also required, and type string. Yeah, type string, and also required true. Next, we need amount with type number and required true. Amount is the amount of money being transferred, deposited, or withdrawn. It's a number and required true. Let's create type. Type describes the transaction type, which can either be transfer, deposit, or withdrawal. Okay, transfer, next deposit, and the last is withdrawal. It is required true. Let's check. Yeah, required. We need to required true. Next, we need date with type date, and by the default it is date.now. Yeah, default date now. Next, we need status with type string and with enum. Enum with pending, completed, and yeah, completed and failed. By the default, it is pending. Yeah. Let's create a mongoose model named transaction. Yeah, mongoose that model name transaction, and we use our transaction schema. Let's export the transaction model. Yeah, and that's it. We created all models. Okay, let's summarize. We created the user model with username, email, password, profile image, date of birth, they joined, NFT likes, wallet transfers, and action bits. Next, we created follow model with follower, followed, date followed, and yeah. Next, we created auth response with token and user. Next, we created NFT model with name, description, price, auction and time, likes, creator, collection, and image. Next, we created collection model with name, description, creator, NFTs, and date created. Next, we created auction model with NFTs, starting price, current bid, and time, bids with bidder amount and date bid. And that's it. Finally, we move and create wallet model.js with user, wallet ID, balance, currency, and created function generate unique wallet ID. And transaction model.js with sender wallet ID, receiver wallet ID, amount, type, date, and status. And that's it. We're done with our models. Let's take a look at our plan. We've just finished with our models, and now we can move on to the controllers. Yeah, we need to create 4 controllers: auction controller for auctions, auth controller for authentication, NFT controller for NFTs, and wallet controller for transactions. Let's finally create our first controller. We'll start with auth controller.js. Okay, .js. Here we need the user model. Let's import user from models, user schema, and user model, and .js. Yeah. Then we need GVT to generate a GVT token. GVT from JSON web token. Next, we need bcrypt for password hashing from bcrypt.js. We also need the wallet model because when a user is created, their wallet is created as well. Models, financial schema, wallet model.js. Let's define. Okay, oops, not. Let's define an async function. Let's start with register. Okay, register, which takes request and response. This function will handle user registration and wallet creation. Let's try catch and let's create const. Where here we extract username, email, password from request body using object destructuring. There are the values the user submits when registering. Next we check if any of these fields are missing. If they are, we return a JSON response informing the user that all fields are required. Let's check and return a JSON response. Yeah. Let's copy and paste. Okay. Let's check in if the email already exists. We need to find a user with email. Okay, email. And now we check if a user with the provided email already exists in the database using user find one email. If the email is found, we return an error message saying that the email is already in use. Let's copy and paste. Okay, the next. Here we ensure that the password is at least 5 characters long. Yeah, if it is too short, we send a message asking the user to choose a stronger password. Let's return res.json and copy and paste. Okay. Next, we need to hash the password. We need to hash the password for security. We generate a salt using bcrypt.gen salt 10. Yeah. Then we need to use encrypt the password before saving it to the database with bcrypt.hash, and we need password and salt. Okay, it's password and salt. Okay, let's check. Okay, let's default profile image. We set a default profile image URL for the new user. This ensures that every user has a profile picture when they register. Let's say, okay, let's copy. 1 second. Let's copy and paste. Okay. Let's create a new user. New user instance with the user model, setting its properties with the provided username, email, and the hash password. Then we save this user to the database using await user.save. Let's hash password, profile image, and let's save this user in database by await user.save. Await user.save. Okay, we save the user in database, and we also need to create a wallet for them. Okay, let's create new wallet. We pass the user ID as a reference to link the wallet to the registered user. Yeah, okay. Check. Yeah, right. Then we also need to save the wallet to the database. Await new wallet. That save. Okay, if everything is successful, we need a JSON response with a status code 201, indicating that the user and wallet were successfully created. Okay, message user and wallet created successfully. And we need to return user and new wallet. Wallet, new wallet. Okay, let's move in catch. Finally, if something goes wrong, our catch block handles the error and sends a 500 status code with an error message. Okay, we created function register. Let's check if all is right. Okay, we created exist, we check email, we check password, we create hash password, profile image, we created new user, we save user, and we also created new wallet for user. Also save wallet in database and return status or error. Okay, let's continue and create the login function. Let's function login request response. We're also using try catch. Here we'll simply copy the catch block from the register function and change the error message to a new one. Let's paste. Okay. First we extract email and password from request body. These are the credentials the user submits when trying to log in. Next, we need to search for a user with a provided email. Let's check user, await, user that find one, email. If the email exists in our database, we process with authentication. If the user is not found, we return a JSON response with a message saying that the user does not exist. This prevents invalid login attempts. Okay. If the user exists, we compare the entered password with the hash password stored in the database using bcrypt.compare. Okay, and we need password, and we need user.password. This function returns true if the passwords match and false otherwise. Okay, check is match. Let's check if is match true. We create token with GBT that sign. We generate a GBT token using GBT sign. This token contains the user's ID and is signed with a secret key stored in process.env secret. But we need to create a secret in .env. Let's create a secret. We also need expires in 7 days. And finally, we return the token in the response. But if the password is incorrect, we return a JSON response indicating that the credentials are invalid. Let's copy and paste. Let's go to .env and create our secret. Let's copy. Okay, secret NFT market 1, 2, 3. Okay, that's it. We create a function login, create find user with email. If is not found user, we return false. We compare password with user password. If it's match, we return token. If is not match, we return message invalid credentials. Let's create a logout function. async function logout request response with the try catch, and let's copy everything and paste it into the catch. Okay, in the try we should just return a successful exit message, and that's it. That's all we need. JSON, let's return, copy and paste. That's it. Okay. Let's now move on to creating the function or for retrieving the user profile, but before that we need to set up Redis using Docker. You can simply find all this code in the repository and copy it. Here we are setting up Redis with Docker, which we'll use to retrieve data much faster. This is because on repeated requests the data will be fetched directly from Redis instead of querying the database every time. Okay, let's wait. Okay, now that everything is up and running, we need to create a Redis.js in config. Let's create Redis.js. We will connect to our local Redis instance in Redis.js. Let's start by importing. We need to import create client from Redis client. Yes, Redis client. But before that, we need to install this dependency. Okay, Redis client. As you can see, we don't have it installed yet, so we need to install it first. Let's open another terminal and install Redis. Okay, wait. First we need to navigate to the backend folder, and let me quickly check if we are in the correct directory. Let's check. Okay, yes, everything is correct. Now let's run the installation. Redis client. Oops, I made a small mistake. Let's try again. Let's copy, paste. Now it's installed and we can continue with our Redis setup. Okay. First we create Redis client using create client. Yeah, we need to use create client. The URL is set from process .env.redis, but now we just create first we need maybe port host is localhost, and we need port yeah, 6379. It's port for Redis. It's default port. It means Redis will run locally. Okay, next we set up an event listener for the connect event. When Redis successfully connects, it logs connected to Redis, to the console. This helps us confirm that the connection is working. Next, we listen for the error event. If Redis have any issues, it logs Redis client error along with error details. This is important for debugging connection problems. Let's console error Redis client error and return the error. And now we use an immediately invoked function expression to connect Redis async. Inside the function we use await client dot connect to establish the connection. If successful, it logs Redis client connected. Let's Redis client connected. But if there is an error, we catch it and log Redis client connection error, followed by the error message. This ensures our application doesn't crash if Redis is unavailable. Let's Redis client connection error with error. Finally, we need to export the client so we can use it throughout our application. And that's it. Yeah, save all. Okay, let's create our function, the next function. But we need to import our client from Redis.js. Okay, let's create async function, get profile with request response. And also with try catch, and let's copy catch and paste. we need to user ID and cached user. We use client get to retrieve data from Redis using a unique key format. If we need cache data, we parse it from JSON format and immediately return it as a response, avoiding a database query. Okay, and if cached user, we return JSON parse with cached user. JSON parse with cached user. And the next, if the user's profile was not found in Redis, we query the database using user.find by ID by user ID. And if the user does not exist in the database, we return 404 not found with message user is not found. JSON, let's copy. Let's copy and paste. Now that we have fetched the user data from the database, we store it in Redis. We use client set to cache the user's profile in Redis. The key follows the format that we use in client.get, profile, and user ID. The value is stored as a JSON string and sets an expiration time of 10 minutes, meaning Redis will automatically remove the cache data after 10 minutes. Okay, finally we return the user profile as a response with 200 status and return user. .json user, and that's it. We check if the user in Redis. If cache user, we return cache user from Redis, but if user does not exist in Redis, we check user in database. If user is not exist in database, we return message user is not found and set in Redis user and return user with status 200. Okay, all is right. Let's go ahead and create a function to update the user profile. Let's create a async function, update profile with request response Why error? Oops, we missed function. Let's try catch and copy the code again and paste it into the catch. Let's paste. Okay. Here we are using object destructor to extract username, email, and password from the request body. This means that the user needs to send these fields in a request to update their profile. Let's finding and updating the user in the database. First we find by ID and update. We use request.user.id. Update the provided fields, username, email, and password, and save the changes to the database. Okay, new, true. If all is right, we send the updated user data back to the client with 200 status. Now the client can see the updated profile, details. Let's copy update user. Yeah. Let's check. Okay, updated user. Okay. We use credentials, updated user, find by ID and update, updated user with okay, res status. Okay, all is right. Okay, let's finally create the last function in Node controller, and it will receive all user notifications. Let's create async function, get user messages with request response, and let's insert the code into our catch again. First we assume that the user is authenticated and their ID is stored in request.user.id. This means that only a logged in user can access their messages. Next we find in the user in the database. Okay, user that find by ID. This user ID and that select with NFT likes, wallet transfers, and auction bids. This searches for the user by their unique ID in the database. This selects only the specific fields we need: NFT likes, wallet transfers, and the last is auction bids. This selects only the specific fields we need. This improves performance because we don't retrieve unnecessary data. Next, we handling the case where the user is not found. If no user is found with the given user ID, we return not found response. Okay, 404 JSON. Okay, message and user not found. If the user exists, we return their NFT likes, wallet transfers, and auction bids. In the response, we use 200 status to indicate a successful request. Okay. Save all. We find by ID, we select NFT likes, wallet transfer, and auction bids. If user is not found, we return a message and response status. Okay, finally we need to export all our function: register, login, logout, get profile, update profile, and the last, get user messages. And that's it. We created register function, we created login, logout, get profile, update profile, and get user messages, and export. This all function. After auth controller, we need to create auth middleware, so that only authenticated people can make certain requests. Let's create auth middleware.js, and first we need to import JVT from JSON web token, and we create function authentication or authenticate request and response, and next. Okay, we check in this function the authorization header in the request. The token is usually sent as bearer token. I'll show you in Postman what I mean. Right now, just copy and paste. Split and 1. Okay, if no token is found, we send unauthorized response. This means the user is not logged in or didn't provide a valid token. JSON message not let's check. Okay, not authorized. Okay, next let's verify the token. In try catch, we use JVT.verify to check if the token is valid, and decoded JVT.verify token and secret. The secret key is stored in data env. Okay, if the token is valid, we extract the user's information. In request that user decoded. Okay. We need export, authenticate, and that's it. Let's check. Yeah, we use token. If doesn't have token, we response message. We in try we verify user's token, and okay, I think it's all right. Now we can start creating our routes. Let's create our routes.js. We need to import Express to create the router and handle requests. Okay. We need to import register from our controller.js. Also, we need other function, login, logout, get profile, update profile, get user messages. Okay, we need to import authenticate. Is a middleware that will verify if the user is logged in before performing certain actions. Okay, let's create express.router. Yeah, we import express, our controllers, and authenticate and create a route. Let's define in the route for creating an action. Let's create register with register function. Let's create router that post / login for login with login function. Let's create router that post with /logout for logout with logout function. We need router that get with /profile. We use authenticated middleware before get profile function. It check if the user authenticated. Okay, we need router that get or that put /profile, but this for update profile, also with authenticate. Authenticate, meaning only logged in users can place can check get profile, update profile, and get user messages also. Okay, get user messages, yeah. Finally, we need to export the router so it can be used in the main application. We need okay, check if all is right. Okay, we created register, login, logout, get profile, we authenticate, middleware, update profile, and get user messages, and export default router. Okay, save all. We need import in server.js our house routes. Let's import. Let's import house routes from routes house routes. Let's check this. Okay, no. Okay, source routes house routes .js. Okay, next we need to create app.use and /house with house routes. Okay, and save all. Okay, look, connected to Redis, Redis client connected, all is right. Yeah. Let's go into Postman and check if our routes and Redis are working. First, let's register, enter the data, and then check what we are asking for in the registration function, meaning what fields we require. Okay, let's check. Okay, username, email and password. We need the username, email and password. We'll let's use test for everything since we're testing. Let's username test, email also test, gmail.com, and password. Password, okay, password, test, password, test 1 2 3, yeah. Okay, as you can see, everything was created successfully, user and wallet. Now let's check our database, refresh it, and we'll see the new user and their wallet. Yeah, user and wallet. Next, let's copy the email and password and try login. Okay, paste and send. As you can see, everything works and we receive the token. Let's copy token. This means we can now perform all other actions. Okay, this is a bearer token I was talking about. This is what we get from the authentication function. Paste this bearer token and let's check. Okay. Now make the request, but for some reason it's not working. I wonder why. No, it's not work. Let's send another one. Okay. Let's try getting the next route. Let's update the user data and maybe everything will work this time. Let's change everything to username. Okay, username, email, email, username, gmail.com, and password, username 123, and send. Okay, for some reason this still is not working. Let's okay, why why is not working? Let's try the last route, and if it doesn't work we have an error in our middleware. As you can see, it doesn't work, and this means there's an error in the middleware. Okay, I'm going to fix it and show you where the issue was. Let's check if our data has been updated, but no, it hasn't. So now I know exactly where the error is. Okay, let's refresh the token one more time and try again. Okay, copy paste. As you can see, the issue is not with the token but with the middleware. Okay, the issue was that we forgot to include next, so it simply was not reaching our function. Okay, now let's fix it and everything will work. Now let's make the request. Okay, and you'll see that everything works correctly and we get the data back. Now let's see how Redis works. On subsequent requests we get a response almost instantly. Okay, let's update the user's data to make sure everything is working. Let's change the token to a new one and we'll see that it's updated. Now let's check our database. As you can see, the user was indeed updated. Yeah. Finally, let's get the user's messages. However, we don't have any yet and we get empty arrays returned. Here is what they look like in the database. Let's start creating the next controller, which will be NFT controller .js. Here we need to import different models. First we will import the NFT model. Okay, let's import NFT model from models, NFT schema, and NFT.model.js. Now let's import our Redis client from config redis.js. After that, we need to import the user model. Okay. Once that's done, we can process with the first function for fetching all NFTs. Get all NFTs, request, not response request, request response. Okay. First we need to extract data from a reg.query. We'll get price, action and time, and likes. Yeah, that's price, action and time, and likes from request.query. Okay, now we need to open a try catch block. Copy the code and paste it inside the catch block. Okay, let's fix error. And first we define an empty filter object. This object will store the filtering conditions based on user input. This means that if no filters are applied, we simply return all NFTs. Let's check if certain filters like price, auction, and time or likes are provided in the request. If they are, we add them to our filter object. Okay, let's check. Okay, action and time, filter, that action and time. This means less than or equal to the given price, that LTE, new date, action and time. If the user provides an action and time, we convert into a date object and filter NFTs that are ending before this time. In likes, this means greater than or equal to the specified number of likes. Okay, greater likes. Okay, we're creating cache key to improve performance. Let's check. Let's check if the requested NFT list is already cached in Redis. We create a unique cache key based on the filter values. This ensures that each unique request has a unique cache key, making it easy to retrieve previously computed results. Okay. auction and time. None. And last, likes. Likes and none. Okay, let's check in Redis cache. Now let's check if we already have this data stored in Redis. If the data exists in cache, we parse it and return it immediately, avoiding a database query. Await client.get cache key. Okay, this step speeds up response time, since Redis is much faster than querying in the database. Let's check cached NFTs and return all NFTs. JSON. Okay, let's check. Okay, we need cached NFTs. Yeah. Let's query in the database. If the data is not cached, we process with querying the NFT collection using the filter we created earlier. Let's find filter. Okay. This query retrieves all NFTs that match the filtering criteria. Let's store in the data in Redis. After fetching the data from MongoDB, we store it in Redis with a 10-minute expiration time to ensure that cache data remains fresh. This means that if another user makes the same request within 10 minutes, they will receive a much faster response from Redis instead of querying the database again. And finally, we return the filtered NFT data as JSON response. Okay. Let's check. Okay. Created. Use cons filter. Filter price, auction and time, likes. We also created cache key, cache NFTs from client.get by cache key, and let's check. Yes, right. Yeah, always right. Let's now move on to creating a function to get a specific NFT. Let's create get NFT request response, open try catch, and copy and paste the code into catch. First, we need to extract the NFT ID from the request parameters. We do this using rec.params.id. This allows us to capture the ID from the URL. For example, if the request is made to NFT-123, then NFT ID will be 123. Let's check if the NFT is cached in Redis. Since fetching data from a database can be slow, we first check if the NFT is already storing data or in Redis cache. Here we attempt to retrieve the NFT from Redis using a unique cache key in the format NFT ID. Now we check if we found the cache NFT. If cache NFT exists, we simply return it from Redis, meaning we skip the database query and respond instantly. Okay, JSON and data, JSON.parse and cache NFT. Okay, let's retrieve NFT from the database. If not cached, if the NFT is not found in Redis, we need to fetch it from our MongoDB database using. Here we use find by ID, NFT ID, to search for the NFT directly in our NFT collection. Next, we check if the NFT exists. If there is no NFT with the given ID, we return error to indicate that it doesn't exist. Let's write status 404 and JSON. Let's copy and paste. Okay, NFT is not found. Let's store the NFT in Redis for future requests. Since the NFT was not cached, but we just fetched it from the database, let's store it in Redis so future requests are much faster. We save the NFT in Redis using the some unique key, NFT ID. We use JSON stringify NFT to convert the object into a string before storing it. Okay, stringify NFT and X means the data will expire after 10 minutes. Okay, and now return the NFT to the client. Okay, JSON NFT, and the user gets the NFT data whether it was fetched from Redis or the database. Let's check. Okay, yeah, cache NFT, NFT. If does not exist NFT, return message NFT is not found. Okay, set NFT in Redis and raise status JSON with NFT. Yeah. Let's now create a function to create NFT. Async function create NFT is request response. Let's open try catch. As always, we insert the code in catch. Let's copy paste, and here we need to first get the data from request body. We need name, description, description, price, auction and time, and image with collection from request that body. Okay. Let's make sure that the user provides all the necessary details before creating an NFT. We check if the name, price, and auction and time fields exist. Okay. Here's what happens. If any of these fields are missing, we return 400 badge request response. This prevents invalid NFTs from being created in our database. Let's copy and paste. Okay, next we need to create a new NFT object. Now that we validated the input, we create a new NFT using the NFT model. Let me break this down: name, description, price, action and time, image, and collection. Okay, these are values coming from the request body. Okay, creator, request that user, and that ID, or okay, now let's save the NFT to the database. We need to store this NFT in our database by .save. This command inserts the NFT document into MongoDB, and finally returns the created NFT. We send a created response back to the client with the created NFT. Save all, check if all is right. Yeah. This confirms that the NFT was successfully saved and returns all its details. Okay, let's check. Okay. Good. Now we need to create a function to update the NFT. Update NFT request response. Let's open try catch and insert the code into catch. Okay, we also need to get the data that we want to change from request that body. Name, description, price, auction and time, collection, and image from request that body. We use find by ID and update to locate the NFT by its ID and update its details. Okay. Find by ID. Reg.params ID gets the NFT's ID from the request URL. And we need updated values that we want to save. And the last, we need new true. Ensures that we return the updated NFT, not the old version. One second. Okay. Next. Next, handle NFT not found. What if the NFT does not exist? We check if updated NFT is null, meaning the ID was not found in the database. If there is no NFT with the given ID, we return 404 not found error. This prevents us from trying to update something that does not exist. Okay, message. NFT is not found. And finally, let's return the updated NFT. If everything works correctly, we send back the updated NFT data with 200 status. Means the update was successful. The response contains the NFT with all the new values. Okay, let's fix error and this. And okay. Let's check. Okay, request body, updated NFT, find by ID and update. Okay. If yeah, all is good. Okay, let's also create a delete NFT with request response. Okay, we need to open try catch and copy and paste code into catch. Okay, the first thing we do is find by ID and delete to search for the NFT by its ID and remove it from the database. Okay. Request.params.id. Retrieve the NFT ID from the request URL. We check if deleted NFT is null, meaning no NFT was found with the given ID. If the NFT does not exist, we return not found error. This prevents us from trying to delete something that's not in the database. Okay, message. NFT is not found. Let's copy paste. And finally, if everything works, we send back a success message. 200 indicates that the NFT was successfully deleted. The response contains message to let the client know that the NFT is gone. Okay. Delete NFT, successful. Okay, let's check. Find by ID and delete. If NFT is not found, return message. Okay. Okay. Good. Save all. Now we need a function to like NFT. Let's create function like NFT, request response. Let's open try catch, and the first thing we do is search for the NFT by its ID. Request that params that ID, extracts the NFT ID from the request URL that find by ID, searches for the NFT in the database. If the NFT does not exist, we handle that with 404 error response. This prevents us from trying to like a non-existent NFT. JSON. Message. NFT is not found. Prevent duplicate likes. Next, we check if the user already liked this NFT. NFT.likes is an array storing user IDs who like this NFT. Request that user.id checks if the current user has already liked it. If they have, we return 400 bad request error, preventing multiple likes. Raise that status 400 .json message and message you already like this NFT. Next, add like to NFT. If the user has not liked the NFT yet, we add their ID to the likes array and save the NFT. Add the user's ID to the likes array. That await. Await. NFT.save. Save the updated NFT back to the database. And update NFT owners likes. Now we update the creator of the NFT, so they know someone liked their NFT. Find by ID that creator. Find the user who created this NFT. If the owner does not exist, we return a 404 error. This ensures we are updating a wallet user. Okay, let's return res that status 404. With JSON message User. Let's user who created NFT not found. Okay, next. No. Let's store like information in user model. We store this like event in NFT owner's profile. NFT owner that NFT likes stores likes received by this user's NFT. Okay. Okay, NFT that ID. Which saves the NFT ID and timestamp on the like let's update the user in the database. Await NFT owner that save. Next, send response and log success. Finally, we log success message and return the updated NFT. NFT owner save successfully, and trace that status to 100 that JSON NFT. This confirms that the like has been successfully processed. And let's copy and paste code in catch block. Okay. Okay. Let's check our function. Okay. Yeah. That's right. I think all is right. Yeah. Now we need to make a function so that we can remove our like. Unlike NFT, request response. Let's open try catch and paste the code into catch. The first thing we do is search for the NFT by its ID. Request that params that ID. Extract the NFT ID from the request URL by found by ID. Searches for the NFT in the database. If the NFT if the NFT does not exist, we handle that with 404 error response. This ensures we're not trying to unlike a non-existent NFT. Let JSON message NFT is not found. Okay. Let's remove the user's like. Now we need to remove the like from the NFT's likes array. NFT.likes.filter. Like, okay, like that to string is not equal to request that user.id. This keeps only the likes that do not match the current user's ID. If the user had liked the NFT before, their ID is removed from the array. Let's save the updated NFT after removing the like. We save the changes to the database and send the response. Finally, we return the updated NFT. Okay, this means the request was successful. Let's export all functions. First, we need get all NFTs, get NFT, create NFT, update NFT, delete NFT, like NFT, and unlike NFT. Okay, we created get all NFTs, get NFT, create NFT, update NFT, delete NFT, like NFT, and unlike NFT functions. Now we need to create routes. This will be NFT routes that JS. Here we need to import Express from Express. Then we need to import our middleware from authentication check, and of course we need to import all our functions with NFT controllers. That's NFT controller .js. Get NFT, create NFT, update NFT, delete NFT, like NFT, and unlike NFT. Okay, next let's create our router. Okay. Let's check our import. Yes. Okay, first we need router that get this fetch all NFTs from the database. Yeah. Creating a new NFT with oh no, we fetches a single NFT, but it unique ID. Yeah. Next, we creating a new NFT with post and with authenticate. Yeah, create NFT. This route allows us to create a new NFT. Why does we use authenticate? We want to make sure that only logged in users can create an NFT. If a user is not found or authenticated, they will be denied access. Let's update NFT with method put, and let's create delete for delete NFT. Here we allow users to delete an NFT. Only authenticated users can remove NFTs. Let's create post liking an NFT. This allows a user to like an NFT. Of course, with authenticate middleware to check that only a logged in user can like NFTs, and unliking an NFT with post method. This route lets users remove their like from an NFT. Just like the like feature, users must be authenticated. Yeah, authentication, middleware, and unlike NFT. Let's exporting the router so that it can be used in our main application file in server.js. Let's check. We created get all NFT, pass, get all NFT, get NFT, create NFT, update NFT, delete NFT, like NFT, unlike NFT with authenticate middleware, and export. Okay, and of course we need to import all this into server.js. Let's first import our NFT routes. NFT routes from source routes NFT routes.js, and then write our app use for NFT routes slash NFTs and use NFT routes. Okay, save all and go in Postman. Don't worry about this warning, it's normal. Okay, let's check if everything is working correctly. We'll start by creating an NFT. Here we need fields like name, test, description, test, NFT, next price, price 3, and of course, auction and time. But let me check how we should properly pass the time format. Let's move to my another workspace and copy. Okay. Well, this. To avoid mistakes, let's just copy and paste these values into our request. Okay. Let's send. As you can see, the NFT was successfully created, and we can verify this our database. Let's refresh MongoDB, and our new NFT should appear. Yeah. Now let's test the other route. We'll start by fetching all NFTs, and as you can see, we get all the NFTs available so far. Next, let's retrieve a specific NFT by its ID, and as expected, we get the correct NFT. Also, Redis caching is working, since retrieving the same NFT again returns a cache response. Look. Now let's update an NFT and check if everything works properly. We'll update name, description, and price to hello NFT. Let's check name, description, price. Okay. Name name hello NFT. Description hello NFT, and price maybe 9, and send. Let's check the database to see if the update was successful, and as you can see, it really worked. Next, let's delete an NFT from the database, but before doing that, we'll create another NFT that we will later delete. Okay, NFT for delete, test, and description, yeah, price 5, and okay. Let's check if the second NFT was successfully created in the database, and yes, it's there. Now we can delete it. Okay, bearer token, and paste ID. Let's say check. Okay. As you can see, the NFT has been deleted and it's no longer in the database. Yeah. Now let's like an NFT. Okay. /like bearer token. Now the like was added successfully. Let's verify the database. Refresh. And yes, the like is stored correctly. Also, the NFT owner received a notification that their NFT was liked. Yeah. And that's it. We successfully created the NFT controller, and everything is working perfectly. Now we can start creating auction controller. Let's create auction controller .js. Here we need to import the auction model. Let's import auction model. From models, NFT schema, and auction model .js. And then we need the NFT model, and Mongoose, from Mongoose. Oops, Mongoose. We still, of course, need to import Redis client. From config, Redis.js. Well, and we also need the user model. And finally, we can start creating the first function to create an action. Let's create async function, create action, request, response. First, we extract the necessary values from reg.body. NFT, the ID of the NFT that will be auctioned. Starting price, the initial bid price for the auction. End time, the time when the auction will end. Okay, from reg.body. Okay, let's open try catch and copy code into catch. 1 second. Okay, paste. In try, let's validate in the NFT ID before processing. We validate the NFT ID to ensure it's a correct MongoDB object ID. Okay. If the ID is invalid, we return a 400 status with an error message. Let's return res.status 400.json message invalid NFT ID. Let's check in if the NFT exists, we fetch the NFT from the database to ensure it exists. Let's await NFT dot find by ID and NFT. If the NFT is not found, we return 404 error message. Press that status, that JSON, message, NFT is not found. Next, creating a new auction. If the NFT exists, we process to create a new auction. The NFT being auctioned, starting price is the initial bid price, current bid the current bid, starting at the same value as starting price, and time the expiration time of the auction. Seller, the user who created the auction. Let's end time. Seller request that user.id. It is the user creating the action. Let's save in the auction to the database. We then save the action to the database. If everything is successful, we return 201 status along with the newly created auction. And let's check function. Okay, we check NFT ID. Okay, we find NFT by ID in database, and okay, if does not exist NFT, return message and create a new action, and save new action in database. Okay, let's now write a function to get all the auctions. Function get all auction, request response, open try catch and paste the code into catch. First, we check if the auction data is already cached. We query the Redis cache to see if we already have auction data stored with the key all auctions. Client.get all auctions. We'll return the cache data if it exists, or null if it's not available. Let's return in cache data. If cache data is found, we return it immediately to avoid fetching it from the database again. If the cache contains the data, we parse it using JSON .parse. and set it as the response. This saves us from making another database query and improves the performance of our API. Let's fetch in auctions from the database. If no cached data is available, we process to fetch the auctions from the database. We use action.find to get all auctions from the database. Populate NFT ensures that the NFTs related to the auctions are also retrieved, making it easier to get complete auction information. Let's cache in the auctions. Once the data is fetched, we store it in the cache for future use. We use client.set to store the fetched auctions in the Redis. And X600 option ensures that the data will be cached for 600 seconds, 10 minutes. This way, the next time the API is called, we can fetch the auctions from the cache instead of querying the database. Okay, 600, and let's return the auctions finally. After caching the data, we return the actions as a response. We send the actions back to the client with a 200 status code, indicating that the request was successful. And let's check. Yeah, we get all auctions. If cache data, we return. Find NFT auction, client set, and response auctions. Okay, I think it all right. Let's create async function for get auction. Okay, paste code, and first we get the auction ID from the URL parameters. This retrieves the auction ID that the user wants to fetch. The ID is part of the URL, and we're extracting it using reg.params_id. Next, we check if the auction data is available in the Redis. We use the auction ID to check if already have the auction data cached using the key auction ID. If this data is available in the cache, we can avoid querying the database. Let's client.get auction ID. If the cache data is found, we return it immediately. If the auction data is found in the cache, we parse it with JSON.parse and send it back as a response. This makes the response faster by retrieving the data directly from the cache rather than querying the database. Okay, data JSON.parse and cached auction. Okay, if the action is not in the cache, we fetch it from the database. We use auction that find by ID. auction ID to find the auction by its ID in the database. That populate NFT ensures that we also retrieve the associated NFT data, so we have all the auction details in one go. Okay, populate NFT. If the auction does not exist in the database, we send 404 response. This checks if the auction exists. If it doesn't, we return a 404 not found response with a property message. Okay, auction is not found. Okay, once the action is fetched from the database, we cache it for future requests. We store the fetched auction data in the Redis cache using the key action ID. The X600 option ensures that the cache data expires after 10 minutes, so it remains fresh and isn't stored forever. Okay, finally we send the auction data back as a response. We send the action data as a response with the 200 OK status, indicating that the request was successful. Okay, save all and check. Okay, client.get if cache action. Okay, auction find by ID. Okay, if auction is not found. Okay, client.set. Okay, and res auction. Okay. Let's now make a function so that we can place bids on the auction. Bid amount. No. Bid on action. Yeah. Request, response. Here we extract bid amount from the request body, which is the amount the user wants to bid on the auction from reg.body. Let's open try catch and copy and paste code into catch. Let's find the auction by ID. We use reg.params.id to get the auction ID from the URL and fetch the auction from the database. Await. Await auction. Okay, 1 second. Sorry, 1 second. Okay. Auction that find by ID. rec.params.id. Okay, next Next, we need to check if the auction exists. If no auction is found, we return not found response. This ensures we don't process a bid for a non-existing auction. Okay, res.status. JSON with message. Let's copy and paste. Okay, let's validate the auction time. We check if the auction has already ended. If the auction end time is in the past, we return a 400 bid request response. New date. Return res.status and 400.json with message auction is over. Let's copy and paste. Okay, next let's validate the bid amount. The new bid must be higher than the current bid. If the user tries to bid an amount less than or equal to auction.current bid, we reject the request. Let's return res.status. .json with message the bid amount must be higher than the current bid. Let's paste. Okay. The next we need to update the auction with the new bid. We update current bid to reflect the new highest bid. We add a new entry to the bids array, recording the bidder's ID and bid amount. Okay. Okay, bidder request.user .id and amount. It is bid amount. Okay, next we need to save the updated auction. We save the updated data back to the database. Let's notify all users about the new bid. We retrieve all users from the database because every user should be notified about the new bid. Okay. Let's create a notification message that includes the bid amount, the NFT associated with the auction. Okay, new bid of bid amount placed on auction for NFT. Auction.nft. Okay, let's loop through all users and add a notification to each user's auction bids array. Okay, user that auction bids that push, and we push auction ID. It's auction.id. Next, we need maybe bid amount. We also need timestamp with new date. And of course message. Message equal notification message. And we save each user's updated data to the database. Let's await user.save. Okay. Let's finally return the updated auction data with 200 OK status. .json .auction. Okay. Let's check. Save all. Okay, bid amount. Find the auction ID by ID. Check if the auction exists. Validate the auction time. Okay. Validating the bid amount. Update the auction with the new bid. We update current bid. Okay. Okay, save the updated auction. Notify all users about the new bid. Okay, create users. Okay, loop through all users and save each user's auction bid. Yes, okay, all is good. I think that's it. Let's go to the last function in this controller. Here we will get the largest supply in the auction, largest highest bid in the action. Okay, open the try catch and copy and paste code in the catch. Here we query all auctions from the database using auction.find. However, we don't want to retrieve every auction, only the top 5 with the highest bids. Okay. That sort. Current bid. We sort auctions in descending order by current bid. This means the highest bids will appear first in the list. limit the results to 5 auctions. Okay, populate related data. We use that populate NFT to replace the NFT ID with the actual NFT details from the database. We also use populate seller to fetch seller information instead of just returning the seller's ID. And send the response with 200 status. Okay, we find actions, sort by current bid, limit 5, populate NFT, populate seller, and raise that status with auctions. Okay, we need to export all functions in auction controller. Let's create auction, get all auctions, get auction, and bid on action, get bids. Okay, now we need to create auction routes .js. Here we need to import Express from Express. Then authenticate middleware. Of course, we need our function with the auction controller. Create auction, get all auctions, get auction, bid on action, and get bids. Now we can create a router. Okay, that router. Oh, okay. Next, here we are using Express.js to define API endpoints for auctions. Okay, router.post with authenticate middleware and create auction. The authenticate middleware ensures that only logged in users can create auctions. Let's router.get get all auctions without authenticate middleware. Router that get by ID, get auction, next bid on action with that post /ID/bid. We use authenticate middleware. Authenticate middleware and bid on auction function. The last we need router that get for get top bids /top and get top bids without authenticate middleware. Finally, we export the router so it can be used in our application in server.js. Okay, let's check. Okay, create auction, get all auctions, get auction, bid on auction, and get to bids. Okay, that's it. Save all and move on server.js and import our auction routes. From routes auction routes.js. Let's up that use for auction routes /auction auctions, and we use auction routes and save all. Okay, let's now check the operation of our functions. Let's start by creating an auction. We need the ID NFT. Let's go and take this ID in the database. Let's insert this ID, and we also need the starting price and the end time. Starting price, okay, starting price 11, and end time. Okay, let's go and copy the end time so that I can enter everything myself. That's okay. Let's find. Okay, that that's what we need, and let's just copy and go back. Okay, let's paste. Oops, let's fix everything. Okay, send. Okay, as you can see, we have an error for some reason, and I don't understand why. 404 not found. Okay, we seem to have entered everything with you, but we have an error for some reason. Okay, let's check. NFT, starting price, and time. Okay. Okay, let me try to solve it now. There is obviously nothing in the database either, and this is bad. Maybe I copied the ID NFT incorrectly. Let's check how we send the request here. Go. Okay. Okay, let's go back. Okay, paste, and nothing changes, and we need to solve the error. Okay, I found a mistake that I made, and I accidentally imported house roads again and not auction roads. Fix it and everything should work. And as you can see, now everything is created successfully. Let's check. Let's check if everything was created in the database, and there is a new auction. Everything works well. Let's now get all the auctions, and here too everything works. We have only one auction and we see it. Now let's find only this auction. Okay, we need auction ID. Okay. Let's copy the auction ID and find it. And everything is successfully found for us, and this means that everything is working fine. Okay, next let bid on auction. Okay, here we get the bid and the auction itself on which we want to place a bid. Okay, bid amount. Okay, and auction ID. But for some reason we have an error, and let's find the reason. Okay, let's check auction roads. Oh, okay. We just forgot to add slash bid. Now everything should work. The bid was placed, and let's now check our database. And as you can see, the current bid has increased, and it shows the bid, and it also shows who placed the bid, and everyone receives a message about the bid. Let's now get the highest bid to the auction. Okay, and for some reason we have an error. Why? Let's try to solve it. One minute, and I try to solve this error. Okay, but why? Okay. It looks interesting. Oh, I found the reason, and you just to comment out this line of code. That populate seller and move get top bids above get auction, and everything should work. I don't understand why, but it really didn't work because of this. Let me show you now that it really works now. Go Postman, and as you can see, everything works for us. And yes, everything works. And next we can move on to the next point. Okay, let's check. Right. Let's create the last controller, and this will be wallet controller.js. Here we need to import the wallet model. Then the transaction model. Okay, transaction. From models, financial schema, and transaction.model.js. Then we need the Redis client. Then we need the user model. And finally, we can start creating a function to get the wallet. Request, response. Let's open try catch and paste the code into catch. Let's fix error. We need to create a cache key that uniquely identifies the user's wallet. This key is based on the user's ID, so each user has a separate cache entry. Okay. Next, let's check in for cached wallet data. Here we query Redis to check if the wallet data is already cached. If data is found in cache, we immediately return it. Okay, cache key. Okay, if cache wallet, we immediately return it. We use JSON.parse because the data in Redis is stored as a string. Let's copy and paste. Next, we need to fetch in wallet from database. If the wallet is not found in the cache, we fetch it from MongoDB using Mongoose. Okay. Request that user.id. Okay, if the wallet is not found in the cache, we fetch it from. Oops, we already do this. If no wallet exists for the user, we return a 404 error. And return message wallet is not found. Okay, let's store the wallet data in cache. After retrieving the wallet from the database, we store it in Redis. We convert the wallet object to a JSON string using JSON.stringify and sets an expiration time of 10 minutes. So the cache automatically clears after 10 minutes. And finally, we return the wallet data as JSON response. Okay. Save all. Let's check. Create cache key, cache wallet, client.get cache key. Okay, if cache wallet will return immediately. Okay. We find user wallet. If wallet is not found, okay, client set. Yeah. I think all it's good. Let's create the last function for sending money. Okay, transaction, no, transfer funds. Let's open try catch and copy and paste code into catch. Okay, first we need to extract the receiver wallet ID, the recipient's wallet ID, and amount from the request body. This tells us who will receive the money and how much will be transferred. Okay. Next, we need to find in the sender's wallet. We search for the wallet of the user making the request. But first we need to find sender wallet. Okay, reg.user .id. If the wallet does not exist, we return 404 error. Let's return press that status 404.json. Message: your wallet is not found. Let's check in sender's balance. We check if the sender has enough balance to make the transfer. If not, we return 400 error with the message return rest status. Okay, that JSON message. And okay, but not receiver, sender. Not enough money on your wallet. Okay, let's find in the receiver's wallet. We search for the recipient's wallet using their wallet ID. If the recipient's wallet is not found, we return a 404 error. But first we need to find this wallet. Let's receiver wallet ID. And if the recipient's wallet is not found, we return error. Okay. .json. Message. Receiver wallet is not found. Okay. Next, let's process in the transaction. We subtract the transfer amount from the sender balance, and we add the transfer amount to the receiver's balance. Just copy this code from the repository, but I explained you what this means. We just subtract the transfer amount from the sender balance and we add the transfer amount to the receiver's balance. It's easy. Let's save in the updated wallets. We save both wallets to update their balances in the database. Okay, receiver wallet, that's save. Let's create a transaction record. We create a new transaction record that stores sender's wallet, wallet ID, receiver's wallet ID, amount transferred, transaction type, and that's all. Let's start with sender wallet, wallet ID. Next we need receiver, receiver wallet ID, receiver wallet, wallet ID, amount, and type transfer. Oops. Transfer. Let's update in the receiver's user data. Okay. Let's find by ID receiver wallet ID. We find receiver user. We find the receiver's user account using their wallet's user ID. But if the receiver exists, we we log the username for debugging. Next, we need to add the transfer details to their history and save the updated user data. Let's first log receiver user and that username. We just log the username for debugging. Let's add the transfer details to their history. Okay, amount and timestamp. Okay. Next, we need to save the updated user data. And we need to console log user updated with transfer message. Okay. But if the receiver user does not exist, we log a message. Okay, receiver user not found for wallet ID. And receiver wallet ID. Okay, let's save in the transaction and send in response. Okay, we save the transaction in the database. Finally, we need to send a success response with the transaction details. Message, transaction is successful, and return transaction. Okay, we check red party, find sender wallet, receiver wallet. Okay. We check balance sender wallet. Okay. We change balance, save wallet, create transaction. Okay, find the receiver user. Okay, push into wallet transfers, transfer. Okay, save receiver user and save transaction and return success response. Okay, we need to export these functions, get wallet and transfer funds. And I think that's it. Okay, let's now move on to creating routes for the wallet. Wallet routes .js. Here we need to import Express from Express. Also, we need to import authenticate middleware .js. Then we need our necessary functions with our controller, get wallet and transfer funds. And we need to create our router. Okay. We need to create router.get slash and authenticate middleware and get wallet. Okay, we need router.post slash transfer we need also authenticate middleware and transfer funds function. Let's export our router. Okay, let's check. We import controllers, constructors, get wallet, transfer funds, we authenticate middleware and export default router. Let's go to Node.js and import our wallet routes. Okay, wallet routes. From routes, wallet routes.js, and let's go to create Axios for wallet routes. Okay, slash wallets, and we use wallet routes. Okay, that's it. Let's go to Postman. Okay, let's first create another user for the future to who will transfer money. Okay, let's copy for future and let's get our wallet, and as you can see everything works for us. Let's now make a transfer, and we need our wallet ID and the wallet ID of the person to which we are transferring. Receiver wallet ID. Okay, paste, and the amount that we want to transfer. Okay, let's check the wallet ID. Okay, Copy, paste. Let's check the wallet ID in the database. Okay. Yeah. Okay. Okay, as you can see, everything was sent successfully. Here we even have the output that we transfer money to Dennis. Now let's check the database, and for some reason it added money incorrectly but took it away correctly. Okay, why? Okay, let me try to find the reason now, and I show you what the error was. Okay, I found the reason, and we need to change the previous two lines to these two, and we will have everything added correctly. Let's now show you that everything worked for us. Let's now transfer 900, but only from Dennis' wallet to my wallet. As you can see, I have already tested and everything was taken away normally in our database. As you can see, everything matched and everything was added correctly in the database. Look, okay, and this is very good. Now we can send another transfer to make sure that everything is working exactly. And as you can see, everything really works now. Now we are done with our controller and routes. Okay, let's summarize that we are creating this part with you. We created get wallet, transfer funds in wallet controller. We create get all NFT, NFT controller, house controller, auction controller. We created house middleware for authenticate. We created a transaction model, wallet model, auction model, collection model, NFT model, house response model, follow model, user model, auction roads, house roads, NFT roads, wallet roads, and create Redis.js and DB.js, and also our server. Let's turn off our server and move on to assembling our project in a container. Okay, sorry, but I just realized that I forgot to show you the wall part of the video, and I'm going to show you now that we need to make a link to our server part when rendering, and we could connect Redis. For this we need to replace our last line in Redis.js with this and create in .env our Redis URL. Then we need to go and create that gitignore file, and we need so that not everything gets into our repository, and we can do something else. These are the things that we ignore. Then let's create a Docker file, and I tell you what we do here. This line specifies that we are using Node.js version 18 as the base image. It includes everything needed to run a Node.js application. This line we updated the package list inside the container. We install snetcat, which is often used for network debugging or health checks. Next, this sets /app as a working directory where our code will be stored and executed. This line copies only package.json and package log.json into the container. By copying these files first, we take advantage of Docker's caching system, speeding up builds. This line installs all Node.js dependencies inside the container. Since we copied only package.json earlier, Docker caches this step unless package.json changes. Okay, this line copies all files from our local directory into the /app directory in the container. Now our full application code is inside the container. This tells Docker that our application will run on port. We use our port. It does not actually open the port, but helps when running the container. And this sets the default command to run the application. Potential issue: the correct command is usually npm start unless server is a valid script in package.json. If your script is called server, make sure it's defined in package.json. This. Otherwise, if your script is called server, use npm server, but if you use npm start, you use npm start. Okay. For now, that's it. And go to docker compose.yaml. Okay. Let's go into docker compose YAML. At the top of the file, we define a section called services. Here we list all the containers that our project needs. Next, image. We create our service Mongo. We use the official MongoDB Docker image Mongo. We name our container MongoDB2 or MongoDB 1, 3, 4, 5. Don't worry about the container name. Choose which you want. This exposes MongoDB's default port, so we can connect to it. Let's go to environment. This set up a root user and password for MongoDB. The default database name is test. This creates a named volume MongoData, so MongoDB keeps its data even if the container restarts. This ensures MongoDB is part of our private Docker network. Let's go to Redis. We use Redis version 7 image. We names the Redis container Redis 2 or whatever you want. Ports exposes Redis on port. It's its default port for Redis, and adds Redis to the same private network. Let's go to app. Build context that tells Docker to build the app from the current directory. Docker file uses our exciting Docker file, names the app container app2, exposes the app on our port. We in environment we define the connection string for MongoDB and secret. This is a secret key used for authentication. Let's go to depends on. This ensures that MongoDB and Redis start before the app does. This means waits for Redis to be ready before running npm start. This prevents errors if the app tries to connect before Redis is available. This we defines the MongoDB volume to persist data, and this creates a private bridge network called NFT network, so all services can communicate. And this we set up MongoDB, Redis, and the Node.js app in one file. We connected all services using Docker networks. We persisted MongoDB data using a volume. We made sure Redis is ready before our app starts. And to launch this container, we need to write docker compose app d build. I show you these commands and everything will start successfully. We need this command. Docker compose app d and build, and everything will start successfully. Let's go to the next part. And yes, okay, let me show you now that we have our server running without starting the server in VS Code. Look, and we just need to start it in a container. Go to Docker desktop, start the container, and check it in Postman. I'll even show you now that we have Redis running. As you can see, we didn't write the start of our server, but just started the container. And let's go to Postman, and look. As you can see, everything works for us, and Redis works too. This is very cool. Then we will create Redis in render and through our backend there. Okay, let's go. Okay, now we need to go to the render and first create our Redis. So that we have a link to Redis. Just repeat everything after me, and there is nothing complicated here. Okay, let's NFT Redis. Okay. Free and create key value. Okay, after we created NFT Redis, we need to copy this line and go to web service to connect our backend and just repeat after me. Connect our repository. Okay. Docker main backend and Docker file. Okay, free. Paste this line. It is Redis URL. Let's copy this two line and let's try to deploy this web service. Okay, I deploy our backend. It will take some time. Okay. To make it all work, we needed to remove Docker file and Docker compose from that gitignore. It's my that's my fault. Sorry, but okay. Failed, but why? Okay. Ooh, okay, look, I have already connected our backend to the render. So that all those errors will disappear, we needed to write another launch command here and everything will work. We add run. Now let's check through Postman that everything work. We copy our Redis render and look. Okay, everything works for us and we can move on to the front-end part where my partner will show with you full front-end part. And okay, thank you and see you soon. Bye bye.
Hello guys! In this video we'll learn how to make a full-stack application. Thus we will do authorization with it sending to the server, and also we will have an account for each user with filtering whether it is his NFT. And also we will do a profile update and update the NFT itself. Here we can see how we register our account and then log in confirming our information. First we create our account by entering our name, email and password. And after creation we are redirected to the login page where we will enter our existing account, and after that we need to reload the page and we will see how our data is successfully displayed. Here we can see our information that we have entered earlier is displayed here. Now we need to go on the page where we will create our NFT. In this page we create our NFT. First of all we need to upload our NFT from our computer, and then we enter the name of the NFT and a short description. After that, we will choose the time how long our NFT will be on sale and enter the price. After that, we click on the button and see how our NFT was successfully created. And after that, we redirect it to the main page. After our NFT has been successfully created, we go back to the profile and select created, and we see how our NFT successfully displayed. After that, we follow our NFT to the page where it is displayed in detail and see what we can do here. We see the price that we put it and the name. After that, we see on the right side functions such as deleting, adding to favorites, and editing. We add to favorites and see how successfully we added it. Then we go to the edit page and change our name or razor, add a new world and update it. And after that, if that is all successfully, we are redirected to the profile page. We updated the name for our NFT and successfully redirected to the profile. Then refresh the page. We have to wait for some time for our NFT to update. Once it is updated, we can go to favorites to see how our NFT has been added to favorites and go to a separate page to see how the heart icon has changed visually. After that, we head to the general page where all the NFTs will be shown. We go to the NFT created by another user and create an auction by clicking on the button. After that, we bid on this NFT and see how successfully the bid was created and displayed on the screen. After that, we log out from our account and create a new account to get the wallet ID of the other user to transfer the money. First of all, we need to create our new account. We need to enter a new username, email, and password. So you can see how I did it in your screen. So after that, in login page, we need to write email and password to confirm our information. And after that, in profile dropdown, we can see our wallet ID, but first of all, we need to refresh the page to see it. We need to copy this ID, and in our account, we have to paste in this ID for sending. So we log back into our account and return to the same page to transfer the money. So after that, we directly make the transfer by inserting the wallet and the price and see how successful we made the transfer. So we can see successful. After we have made a transfer from wallet to wallet, we log out from our account and we need to log back into our previous new account that we created to see our transfer. First of all, we click on the bell to open our window where the transfer will be displayed and we see our number that we sent. So we can see how our transfer from wallet to wallet work currently. With this video, we began our creation of a massive project. From the beginning, I want to remind you that you should clone the initial repository on GitHub and after that start creating the logic for our project. Here you can see the default main page with styles, pictures and etc. And the frequency page where there is a wonderful custom drop-down menu. And so we begin. I also want to remind you that you should launch our site with the command npm render. After that, we need to create an authorization context. We make a typization, our interface of auth context type. In this auth context type, here will be token, avatar, name, auction ID, favorites, and a couple of functions, such as clearing token, our writing token, and a function describing the registration data, but we will write it later. First of all, our function of set token will be nothing to return, and clear token also. After typing the context, we create our context by passing our typing into it. That is what it will contain or undefine, but later we replace it with Node. Next, we create our states with props children, but then we will have initial values with typing. It will be our states. So these values we take from our interface, but soon after the server's response, they will be overwritten. Now we will prototypize our props as React node and make an interface for our registration function, and define in the interface above it. After that, we are going to create our registration function, where we pass in an interface to iRegister. So in our interface iRegister data will be username that will be string, email that is the same, and password that's also the same. And at the end we add ID that also a string. Then we return to our handler register function And inside the function we write a try-catch func to catch errors. So, in the our Puppet file, we initialize our link to work with the server and import it into our context where we write the function for registration. So, we need to call our backend URL path from our app file in our context. Then we have a function with the method post where we write our path and the data we send. Our data are username, password, and email, and also ID. Here, if we get a response from the server, then we create a variable valid ID, making a check for existence. After that, we need write the code console log to display our response from server. So you can see that if we get a response from the server, then we create a variable valid ID, making a check for existence. Then we also call console log to display our valid ID. Then if it exists, we output it to the console, and we have an existing valid ID, then we put it in the local storage. Also, we output it to the console and override the state as well as if everything is successful. Then you can see that we overwrite our state with a response from the server. So our auth, username, email, token, avatar will be overwrite. And other state also will be override. After that, if user registered, we can check in the console log response from the server. Also, if will be error, we also cannot see. So here, as I said at the beginning, we fix our function in our interface where the handler register function doesn't return anything, and the data will be in the form of our register data interface. So guys, now we create two functions to write our token and delete it, which will be used when I log in out from my account, clear the token state and delete the token from local storage, and we create an auth provider where we pass our states and functions for further use, and create an auth profile hook to access it. So you can see how I created two functions, set token and clear token, and where I added my states and functions into auth context provider. Then I created use auth hook where I typify this hook with auth context type. We create variable context. We use our context where we edit our auth context. If we don't have our context, then we throw new error. And then we return our context. So here you can see that I have changed the name to rewrite the token, to update it in the setToken function, and also I added the valid ID to the typing and to the authorization provider. So now in function clear token you can see that I have changed setToken state. So here you can see that I also changed parts of the code and I added a token to locker storage. So please be very careful and double check the entire code again. So here we can see our complete code. Please be careful and check double. So after checking our code, we go to the header component, where we will have the state of opening our notification or not. And we also call our token from our context and set the station of whether the profile is open. After that, we create an open function and create a click to download function where we have a token check. I want to remind you that navigate should be when some action is performed. For example, like we have that if there is no token during verification, then we will be redirected to registration. So you can see it in your screen. Then we are making function on click that would be open a notification if there are a new messages, as well as an upload function where we also check whether we have a token or not, and also a function to open a mini profile. So after we created our functions, we need to add event handlers such as onClick. After that we entered our functions and they will only work on click. So after that we check that if our user doesn't have a token, then an icon will be shown when hovered over and two links will pop up on which there will be a redirect to our page. So you can see how it works in your screen. So after that I need import user icon from assets. Then we created a button when checking if the user has a token. Then there will be an upload button. If there is no token, then this button will not exist. After that, we should display our pop-up if there was a click on the button on the profile. Then we will display our wallet component. For everything to work correctly, we need to uncomment our provider in the imports and in the wrapper in the main file. And now we check our result. So you can see that correctly is work. I click on the bell and the model window opens where our messages will be visible, but I can't close what exactly is the problem. So we should go back to the component and rename the first thing in the state to open and rewrite it in the function to open. So now we need to go to register page in our code. So we write a constant to call the navigation hook, and also we call our register sending function from the context, and we call the useForm hook where we pass the target of our register. What is this hook? UseForm is a hook from the form hook React that replaces useState and onChange, making forms simpler and more efficient. Register will register the fields in the form, resort the form, and handler submit will turn the form to submit, ensuring the data is valid. We create a function on submit function that handles form data. Submit handler function that accepts data parameters that we typed in the iForm register interface. Our data are fields such as username, email, and password. They get into the data through register function, which access our fields. When we click on the button after that, we will be redirected to the login page. After that, we save our code and go to the register page in our browser and enter our data in the input fields that register will transmit for sending and send. We see in the console that our form has been submitted. We saw an error because CORS blocks HTTP requests. So we have to go back to the code and write a function in server.js file. To allow cross interact with HTTP class. You need to write it like I have. If you have it, then great. Only for origin, write your local code that you have and then try to register from the beginning. We have entered new data for the user, and we see that our user is created in the console. We can see the user information, his wallet ID, and other things. We do the following. Now, we are going to display on the profile button the user's wallet information, namely his ID for the transfer, and also we have to go to Components and select the wallet folder. I would like to say that we have removed the console output and the variable name for registering a new user. In the wallet ID component, we call ausContext that we take the username and wallet ID, and then output them in our code and check. As we see, everything is successful. The wallet ID and username is displayed. So, we must now create a user context to hold information about the user and use it in the code calling our context. As usual, we typify our context so that we understand what data types we are working with. Everything is clear at first, but there are two functions, such as update username and update email. These functions do not return anything as we do not return any data. There is no return, and here we added our code. So in our context of user info will be username, update username, token email, update email, and avatar with balance and user ID. After that, we added our variable of user context, typify our create context, and edit our variable of user info provider. And also we added our states in which values that we needed. So you can see this state in your screen. After that, we log our user ID because we need to use it then. And in the end, we added our states and functions into our context provider. So, we need to change the data type for our name and avatar. And then we add our values to the context value to further code. Now, we import our token to check for user authorization and create a use effect for tracking. We create an asynchronous function inside the effect where we check for the token. If it is not present, there will be an error, and if it is successful, we make a request for profile data by creating a token bearer header. If the data is successfully requested, then we override our states with data from the server by accessing data from the server and write a question mark that we won't get an error if there is no data. If there is an error, then we output it in the dependency array and pass our token to be used for tracking, but before that we call the fetchProfile function. So we create another user effect that tracks by our token. This time we query the wallets by passing the token in the header, and if everything is successful, then we overwrite our balance in the stake, which is 0 by default, and call the function. So you can see how I wrote it before. Then we need to create an asynchronous function to update our username, passing the function parameter new username as a string. Further, we wrap our code in the try-catch function for catching errors and create a variable so we have response from the server. We send the HTTP put method to the specified path and pass the name as a new username, where we write the bearer token for transfer in the header. After that, we override our name with new data from the server, otherwise we display errors. Next, we delete the update email function in the context interface because we will not work with it, and then we transfer our functions to the context provider. Well, then we create our user info hook, which we type with our interface, and create a variable where we will use the context and pass our context. If we do not have our context, then there will be an error. So we go to the login page and start writing our account logic login. We make an interface with password and email value. Now we call out the token function from the authentication context because our token is issued after logging into the account. So we will override out token value. Now we are destruct writing such functions as result, register, and handle submit from useForm hook, which typify as iForm data. You are already familiar with the useForm hook, so let's move on. We write the function and pass out typing, so we say what data is expected to work, and we send this asynchronous function to the server, passing the password and email, and output our response from the server to the console. Then, if we get a successful response and we have a token in the response, we overwrite our token. Also, if we have an error, then we log this error. After that, we add a function to submit our form, which takes in a register that binds our fields to a value and passes it to the function. After that, we go to our user info context because I misspelled the path to the server in update username. We have to put profile instead of register. I completely forgot to wrap our application in context so that we have access throughout our application, and here is importing our provider. So we go to profile in components and start to write our logic here. we call our name and email from our context and also a token from another context. We create a profile data state that contains our user data and calls the navigation and location hook. That is what path we are on. After that, we create an use effect to filter if we are on the profile page. Then we will be redirected to the on sale page. It is also created, and we need an array of dependencies so that we are always redirected and not only when rendering the page. Next, we create another useEffect function to receive data from our server. The function is asynchronous, which means it will only work if called. We also check for the token, and to receive our data, we type the request to understand what data there will be. If there is data, then we rewrite our state and display our data in the code, namely the name, email, avatar, and the date when the user created the account. Then we call our fetch profile function. Friends, I apologize that we must remove the type of our title and on the login page call the navigation hook and add a redirect to the profile page if our data is successfully sent. We will create an account again where we will enter the name, personal, and email, and we must click on the register button, so after that in the console we will see that the data has been sent. And also valid ID is displayed. And that we have registered. After that, we confirm that we are registered and log in, and we can see that in the console the data has been received, and in the profile we need to reload the page and we will see how our valid ID and username are shown. Guys, I want to say that we need to remove username and email from the context in the profile component and remove the context call. Instead, we will call profile data to display username and email, save and reload our site, and we can see how everything is successfully displayed. So guys, now we will revoke our function for updating. We copy our headers and insert into the username function, so that in the context we have user info. Next, we copy the check that if the status is 200, we also insert this check into our context and copy update username, insert in it inside the status check. After that, we go to our function in the update, we call our function from the context and pass our name. After that, we go to the site and enter the name, and we see that everything was successfully sent. The updated data is correct and there are no more errors. Now we can test. We update our name. We can see that everything is successful. And we need to refresh the page. Now we need to go to our header component and update our class name, add one underline element, and now we can see that our upload button has the styles all right. So in our create component, we were using the useState hook to manage some states. First, there is checked, which is boolean, and second, we also have image, which will hold a file or not. Then there is token, which comes from a custom use auth hook. It grabs the user's authentication token, and we can use this token when making a request to the backend to verify the user's identity. Next, we have data, which is an object that will store the details of an NFT the user is trying to create. Things like the name, description, price, auction, and time and collection for the NFT are being stored here. Lastly, there is navigator function that comes from useNavigate hook. This allows us to change roles programmatically so we can navigate the user to different pages in the app based on what's going on. Then we create onChange handler function. This is function that handles changes when a user interacts with an input field. It's triggered whenever the value of an input element changes. Event to.react.change event HTML input is TypeScript. This type annotation tells us that the event is specifically a change even on an HTML input element. Then we destructure the name and value from the event target. This gives us the name of the input field and the value the user has entered. If the input field's name is auction and time, we create a variable local date. where we create a new date with value. The value from the input is treated as a string. Second variable, UTC-date, converts the local date into UTC by using date UTC, which creates a date in UTC time, representing a date and time, so we convert it into a JavaScript date object, and then we are updating the state data by preserving the previous state and updating the auction and time with the new UTC date. If the input's name isn't auction and time, the code falls back to this else block. In this case, we just update the corresponding field in data with new value without any special handling for dates. We create handler checkbox function. This is simple function that toggles the value of the isChecked state. Then we also check if we have a token. If we don't have a token, then we will have an toast error. After that, we create sendPayload function. This is an asynchronous function which is used to send data to a backend server, handle the response, and perform actions based on the result. The function takes a parameter payload of type unknown. This is the data that will be sent to the server, and it could be anything. The function uses a try-catch block to handle any errors that might occur during the process of sending the data. Then we make a post request using Axios to send the payload to server. Then we transmit our payload and the request includes headers for authorization barrier token and specifies that the content type is JSON, content type application JSON. Ensures that the function waits for this request to finish before processing. If the request is successful, it logs a success message along with the response data returned by the server. If the server responds with a status code of 200, 0, and 1, which usually means created, the following actions occur. The image state is reset to null. Clearing any upload image, the form data is reset to its initial state, clearing all the fields, and the user is redirected to the home page. A success message is shown to the user, indicating the NFT creation process was initiated. If there is an error during the Axios post request, it logs the error details to the console. A truth message is shown to the user, indicating that there was an error sending the data. Then we continue our function, and if there is an image, it reads it and prepares it for submission. If no image is provided, it sends the data without the image. A file reader object is created which will be used to read the contents of the selected image file. The read as date URL method reads the image file as base 64 encoded string, which is a format that can be easily sent over the network. When the image file has been successfully read, this happens asynchronously. The unloaded event handler is triggered. Inside the handler, the base 64 image is obtained from reader result, which contains the base 64 encoded version of the image. A payload is created with data that will be sent to the server. Name, description, price, and auction and time are taken from the data state. The auction and time is converted to an ISO string format, and the image field is set to the base 64 encoded image. The send payload function is called to send the payload to the server. Then, if a payload is created without the image, the same fields are included. The image field is explicitly set to undefined because no image is provided. The send payload function is called again, but this time without the image. Then we call our asynchronous send payload function and transmit our payload. Then, if a payload is created without the image, the same fields are included. The image field is explicitly set to underfund because no image is provided. The send payload function is called again, but this time without the image. Then we transmit our onSubmit handler function in our form onSubmit. Then we attach the onChange function to our inputs elements. And after that we create a custom checkbox input. So now we are going to create our inputs elements. So the first input element is a checkbox. It has the onChange event handler, which is attached to the handlerCheck checkbox function. The checked attribute reflects whether the checkbox is checked or not using the isChecked state. Whenever the checkbox is clicked, the handlerCheck checkbox function is triggered, updating the isChecked state. After the checkbox is clicked and the isChecked state becomes true, a second input element of type number is conditionally rendered. The second input is bound to a value, the data.price, and also has an onChange handler, which is attached to the onChange handler function. If the checkbox is checked, the user can enter a price and the changes are reflected by the onChange handler function, which updates the state related to price. Then, in image, when it is rendering an image element based on conditional check, if image is provided true, it will create a temporary URL using url.createObjectURL, which is typically used for displaying locally selected files. If image is not provided false, it will use the value of NFT as the fallback image URL. So now you can see how the event typing in our onChange handler function was changed to HTML input element, and we save our code and go to our browser. and we refresh the page. Finally, we will click Create. We see a message that our NFT has been successfully created, and in the console, we can see the specific details. So, in Discover page, in our code, we have two state variables are being defined using the useState hook. Price is a state variable that holds the value 5 initially. SetPrice is a function used to update the value of price. AllData is a state variable initialized as an empty array. It is expected to hold an array of objects, and type of each object is defined as INFT, meaning the terms in AllData follow the NFT structure. Then we create handler price change function. This function is used to update the price state whenever the value of an input field changes. The function receives an event object that is triggered by a change in an input field. The event type is specifically a React.changeEvent HTML input element, and which refers to changes in HTML input elements. The value of the input field, then number, converts the string value to a number, so the price state can hold the correct numerical value. Then we use useEffect to fetch data from the server when the component mounts. Inside the useEffect, you define an asynchronous function to fetch data from the server. The Axios GET request fetches data from the specific URL, expecting a response with a type of INFT response. If the request is successful, the response data is logged to the console. After receiving the data, the setAllData function updates the AllData state with a data field from the response. If there is an error in the Axios GET request, it's caught by the catch block and the error is logged to the console. After this, we attach the onChanged and value to our input date element, and then we map our AllData. If there are NFTs in the AllData array, we map our each NFT and display them as individual cards. So, the card displays the NFT's image, name, price in ETN, and some avatars representing owners or other users. Also, each card has a link that directs to the individual NFT page using its ID as part of the URL. So I will skip ahead so it doesn't take up time and you rewrite it. I also imported the image from Axios. After that, if all data is empty, a message is shown instead, indicating that there are no items to display. So we save our code and go to our browser. And to ensure that the request for displaying NFT works, we go to the Discover page to display our NFTs. So we can see that everything is good work. Next, we go to the on-sale component to implement the logic here. We call token from useOS and user ID from user info context. We also initialize a state variable sale data with a type of INFT array or null. It will hold an array of NFT that are for sale. Initially, the value is set to an empty array. Then, we use useEffectHook to perform side effects like fetching data when certain dependencies change. In this case, it runs when either the token or the user ID from local storage changes. The empty dependency array ensures that the effect will run only once, but here it depends on token and local storage. Fetch item sale, this asynchronous function, fetches a list of NFTs from the backend that are available for sale by the user. Before making the request, it checks if token exists. If not, it shows an error using toast error. The function sends a get request to the backend with the authorization header containing the token in the format bearer token. After receiving the response, it filters the list of NFTs to only include those who created by the current user. The filtered list created NFTs represent the NFTs that belong to the user. The filtered created NFTs array is stored in the sale data state using setSaleData. If there is any error during the request, it is caught and logged to the console with console log method. The entire block of code is wrapped in a section element with a class name. This section is used to display NFTs that are for sale. Then we check if the sale data array exists and contains items. If there are NFTs available for sales, the code proceeds to render them. If sale data contains NFTs, it uses map method to iterate over each NFT and create a link for each one that navigates to the individual NFTs page. If no NFTs are available, it renders a message indicating that there are no NFTs currently for sale. So those code you can see in your screen. So I skip ahead also. I'm also imported the image from assets. And if no NFTs are available here, it renders a message indicating that there are no NFTs currently for sale. After this, we save our code and go to the website. Then we click on the tab where our NFTs should be displayed. If you don't see them, reload the page and check the console to see if the request was made. After that, we go to our styles and modify the classes to ensure everything is displayed correctly. So you can copy my style from GitHub. After that, we go to our NFT single page component, which will be displayed on the main page. After we send it here, we call avatar with username. So we also create single data is a state variable that will store the information for single NFT. Initially, it's set to an empty array which will be populated with NFT data once it's paged. The type INFT suggests that single data is an array of INFT objects. Current index state is used to track the index of the current item in the list initially. It's set to 0, meaning the first item in the list. Auction and time holds the end time of the NFT's auction, which is a date object. Initially, it's set to null, but it will be populated when the specific NFT's auction end time is retrieved. Time left, the state keeps track of the remaining time in the auction, hours, minutes, and seconds. Initially, it is set to 0 for all fields. Then we use the effect hook. This hook is being used to fetch data when the component mounts or when the current index changes. The dependency array current index ensures that the effect runs again whenever current index changes. We make an API call using Axios to fetch NFT data from the backend. The request is sent to backend URL, and the response is expected to be of type INFTs response. If there is a data, we set single data with the data. Then I filter out NFTs that have a valid auction and time. If any valid NFTs are found, I set single data to the filtered valid NFTs. If no valid NFTs are found, I resort single data to an empty error. If there is an error during API call, it will log the error to the console. Then we use another use effect hook. The first condition checks if auction and time isn't defined or false. If that's the case, it displays an error message using toast error. The return statement ensures that the rest of the code doesn't run if auction and time is missing. Once auction and time is available, the code sets up an interval that runs every second. Inside the interval, it calculates the time difference between the current time and the auction end time. If difference is less than or equal to 0, it sets the remaining time to 0 hours, minutes, and seconds, and clears the interval to stop the countdown. Then, this use effect returns a cleanup function that clears the interval when the component are months or when auction time changes. This ensures that the interval doesn't continue running after it's no longer needed. Then we create handle next function. This function increments the current index to move the next item in the single data array. The modular operator percent ensures that the index exceeds the length of the array. This allows the user to cycle through the array. Then we create handler pref function. This function decrements the current index to move to the previous item in the single data array. It ensures that the index stays within valid bounds, wrapping around the last item of the array when necessary. Then we create current NFT variable that will always represent the current NFT based on the current index. First, we access current NFT in different parts of the code to extract the necessary value. We also use it in the link component to retrieve the ID. Finally, we add two on-click events to apply our functions for switching between NFTs. We also go back to our token check to properly fix the structures and eliminate the error. We save our code and go to the main page to see how everything works. Our buttons for switching NFTs work perfectly. So, then we go to the one item page and we get the ID of the NFT from the URL using use params. After that, we extract from user info context user data such as avatar, username, and user ID. Then we create a state variable NFT data to store the details of the NFT. Initially, it's null. Then we call use effect that runs every time when the ID changes. Inside it, we create fetch NFT details. That is an asynchronous function that sends a GET request to the backend server to fetch NFT details by ID. It updates the NFT data state with the fetched data, logs an error message if the request failed. Then, we access our NFT data in different parts of the code to extract the necessary value. And after that, we save the code and go to the website, click the View Item button and reload the page to refresh and load the data. Then we add a slash before our ID in API code in our code. Because we have an error, and by doing this, we can fix our request for server. So we can see the name and avatar displays successful. Now we are going to add our NFT. We navigate to edit pages NFT in our code and start writing. We create I add NFT interface. This interface defines the structure of an NFT when editing it. Name, description, price, auction and time, data, and image. Then we create is checked state for checkbox. So now we create is check state for our checkbox. Then we are going to use our use NFT hook that provides NFT data. We distribute the values name, description, price, auction time, and image, and update NFT function. But first of all, we retrieve the ID from the URL using use params. This ID is used to fetch or update the specific NFT. Then we create data state that will hold temporary values for the NFT before updating and have default values. Set data is used to update the data state. Then we create selected image state that holds the upload image file. By default, it's null. After that, we create handle checkbox function. It is a function that toggles the state of isChecked. If isChecked is true, it changes to false. If isChecked is false, it changes to true. Then we create an asynchronous function. Inside, we use event prevent default. This prevents the default behavior of the form, which would typically reload the page upon submission. Then, if the ID is not defined, an error message is shown using toSthrow. If ID is missing, the function exists early using return. Then, we convert an auction and time to ISO string, and if an image has been selected, a file reader object is created to read the image file. When the file has been read, the result is stored as base64 image, which will be a base64 string representation of the image. After that, we create the use NFT context by typing our context with NFT context type interface. But first of all, we clean our context and start writing. We rename our interface when you name NFT context type. NFT context type defines the structure of the context for managing NFT data, for example, ID, description, name, price, auction time, auction create, image, update NFT context, and if the context that holds NFT data and it is initialized with now as a default value. It will later be provided to components using the NFT provider to share the NFT state and function across the component tree. NFT provider is a context provider component that allows child components to access the NFT context. These are set variables that hold the current values for various aspects of an NFT. Half of our interface and uses, but we will add them later. Then we call useNavigate hook and token from our useAus context and ID from useParams ID. So now we create fetch get NFT data function. This function is asynchronous function with ID that will be string and typify as promise with void. Before making the API request, the function checks if the token is available. If there is no token, an error message is displayed using toast error function, and the function returns early. The function makes an API GET request to fetch the NFT data using Axios. It includes the authorization header with the barrier token to authenticate the request. We rename our aus context to a new update NFT context name. And now we can import our token from useAus because we change our useAus hook to a new useUpdate NFT hook, which we typicize with NFT context type. Then we successfully can import our token, and the response.data contains the NFT details returned by the API server. The data is logged to the console to view the context, including the auction and time. If the request is successful, the function navigates to the add page for the NFT using navigate function. Set name, set description, set price, set auction and time, and set image are called to set the respective NFT properties in the stake. Set name, set description, set price, set auction time, and set image is our set function to update our state. So the fetch data is used to update the state variables. Then we create another user fetch hook for fetching NFT data. This user fetch hook runs when either the token or ID changes. If the ID is available, it calls the fetch NFT data function to retrieve the update NFT data using the ID. The update NFT function is responsible for updating an NFT's data. Update NFT asynchronous function, ID, name, description, price, auction time, and image. It first checks if the token and ID are available. If not, an error message is displayed using toast error. The function then sends a put request to update the NFT data, passing the name, description, price, auction time, and image. We also have headers authorization with barrier token. If the request is successful, I mean status code 200, the user is redirected to the profile page using navigate hook. It updates the state with the new data, then we add state, values, and function as part of the context value in provider. But now, if we have error, we write it in the console. And now, we transmit our state in our provider. Now we change our name of our export provider in our context and import it in our main file. Then, in edit page, we call these values from our use NFT context, and we return to our code and continue writing it. So you can see that we take name, description, price, auction time, image, and update NFT function from our use NFT context. We return to our function on submit handler, and we call async function update NFT, in which we add our values, ID, description, price, and base 64 image. After that, we create ISO date variable to convert the auction and time, which is expected to be a date or string, into an ISO string format. New date creates a date object from the auction and time value and converts the date object into an ISO string, which is a centralized format. Then we use hook. Use effect hook is used to update the data state whenever any of the name, description, price, auction, and time image values change. It is typically used to synchronize the component's local state with values provided in these dependencies. We also need to create the onChangeHandler function that is responsible for handling the change events of an input element and updating the data state accordingly. The name and value are extracted from the input event name corresponds to the name of the input field and value is entered value. Handler are shown n times separately. If the input name is shown in time, it assumes the value is a date string. It converts the value into a date object using the date value, which is then used to update the option time in the state. For all other fields, it updates the corresponding property in the data state using the name as k and the value as a new value. Then we have checked if we hadn't ID, then we will toss an error. Else, if there is no image, this part of the code calls update NFT without the base 64 image. Using the existing image URL if it's a string or null oversize. You can see now that we are passing this value that we defined in the context. Then everything is the same as we did on the create page before we created the NFT. To summarize, we attach our values and the onChange handler to the input and checkboxes. So now you can see that we add onChange in input element. For example, to upload, to display name, also description, and then a date. Then, if the checkbox is checked, an input field will be displayed. Then, if selected image exists, url.createObjectURL creates a temporary URL pointing to the selected file. This URL can be used as the source of an image in the src attribute. If selected image isn't provided, it checks if image is a string. It uses image as a src. If neither condition is true, it falls back to NFT, which could be a default image or a placeholder for when no image is provided. Then we also add an onChange handler for our checkbox. So guys, next we go to a single component from our useNFT context where we try to call the function, but we didn't pass in the provider. Now we typify our function fetch get NFT data with promise and void. We went back to edit and now we need to type in our interface. After that we call it where necessary and attach the onClick so that when the button is clicked, the function is called. So his is an arrow function execute when the button is clicked. It checks if ID exists, and if so, it calls the fetch NFT get data auction with ID function. After this, we go to the site where we can observe how we update our NFT by clicking the edit button, and after that, we see in the console that it has changed. So now we are going to create the favorite context. First of all, we create interface INFT. This interface defines the shape of an NFT object with properties like image, name, price, and ID. Favorites context type. This interface defines the methods and properties available in the favorites context. It includes favorites, add favorite, get favorites, remove from favorites, functions. The context itself is created using createContext. It is initialized with null and will be used to pass the favorites data and function throughout the app. We create favorites state. It holds the current list of favorite NFTs. It is initialized by checking the local storage for any previously stored favorites. If no favorites are stored, it defaults to an empty array. Add favorite. This function adds a new NFT to the favorites list. Now we are going to do this. It checks if the NFT is already in the list by comparing the ID. If it is, the list isn't updated. Otherwise, the NFT is added and the updated list is saved to local storage. We have typicized our functions, for example, add favorite, in our favorites context type. Then we create the second function, getFavorites. This function simply returns the current list of favorites. And we add our functions into our favorites context provider. Then we also typify this function. So useFavorites hook provides easy access to the context data. And we import it in our app file. Then we return to our OneItem page and then create a state variable tracks, whether the current NFT is in the user's favorites. It's initially set to false, indicating that the NFT is not in the favorites list. We call the functions provided by the favorites context to add, retrieve, and remove NFTs from the favorites list. These functions are used to manipulate the favorites list in the context. UseNavigate hook is used for navigation. It allows redirection to the user's different pages programmatically. And we attach everything to the button using onClick, and we check if we had no favorites, then we use default head, else we have red head. After that, we are going to create handle click favorite asynchronous function that handles adding or removing the NFT from the favorites list when the user clicks the favorite button. The function first checks if there is no token. An error message is displayed within toast.error. We import token from our useAus context. After that, if the NFT is already in the favorites list, then we remove from favorites. The Axios.post method is called to send a request to the backend to unlike the NFT from the user's favorites. The remove from favorites by ID function removes the NFT from the local favorites list. The setIsFavorite false function updates the state to reflect that the NFT is no longer in the favorites. Also, we have authorization header with barrier token. A success toast message is displayed toast success. If there is any error during the process, such as in the API request, it is called by the hash block and the error message is logged to the console. After that, we return to our use favorites context to create the function for removing from favorites. The remove from favorites function filters the current list of favorites and removes the NFT with the provided NFT ID. After filtering, the updated list is stored in local storage to persist the changes. The setFavorites function updates the favorite state with a new list, triggering a render in the component. After that, we need to add this function in our interface, and then we use it in our function in one item page, and we call it and add ID in this function. Then we call our remove from favorites function and add into ID, and then we will have toast.success. After that, we change our state favorite into isFavorite and set isFavorite. Then we create another useEffect hook, and it calls getFavorites function to retrieve the list of favorite NFTs from the context. It checks if the current NFT is in the list of favorites by using the sum method. This method checks if there is an NFT with the same underline ID as the ID in the favorites image list. Also, we import our red heart image from our assets. Then we add if check is favorite. If we have is favorite, then our function will work. I want to remind you that you check the code on my GitHub. Now we add set is favorite false or set is favorite true. Then we save our code and go to our website, and we can see that initially nothing is added to our local storage, meaning the function doesn't work. Therefore, we go into our code and fix it as shown. After that, we try adding again and see how we successfully add it. I will also leave the full code in the description so you can take it if needed. Then we create the handler delayed NFT function that checks several things before attempting to delete an NFT. If the user has a token, authentication check, and if the ID of the NFT is valid, once those conditions are met, an API call is made to delete the NFT from the backend using Axios.delete. Our request includes the authorization header with the user's token. If the delete function is successful, the NFT is removed from the favorites list using the remove from favorites function, and the user is redirected to the home page. A success message is shown. If any errors occur during the process, appropriate error messages are shown using toast error. Finally, this function is triggered when the button is clicked by attaching it to the onClick event of the button, allowing the user to delete the NFT, and then we create a check if the NFT belongs to the user. We saw our code and go to our website, then we click on our profile button, but here is nothing. So we go to our wallet component and call our needs values from context, and we see our balance. You can see it in your screen. After that, we go to our subheader component and we create logout function. So we have async function, and when we will click on our button, then our local storage will delete all values by method clear, and we will navigate in main page and can see successful toast. So we save our code and go to our website. We are going to log out from our account and try to create a new. After successful creation, we can see our wallet ID, username, and balance in our profile button. By click and see that here we haven't any NFTs because our check is open. So now we can test it. We click on Discover page and go to NFT page where we click on the Delete button and we see Toaster. But we can add NFT in the favorites without problem, and we go to our favorites in profile and we start write logic to display here our favorites. So we go to favorite component and call use favorites custom hook that likely manages the user's favorite NFTs. Get favorites is a function that retrieves the list of favorite NFTs. Then we create a variable current bit in which we take from local storage value and the name new bit price. After that, inside section, we have check if favorites is empty. It displays no favorites added here. Otherwise, it maps through the favorites array and renders each NFT. Each NFT is wrapped in a link component from Rotterdam that navigates to NFT by ID. Is the favorite ID is a unique identifier for each NFT, and then we display information about favorites NFT, and we take the data from map function and display variable current bit. Then we will go to our site and we will see that everything will work correctly. Then we go to our use NFT context and create fetch get NFT auction function that is an asynchronous function that retrieves auction data for an NFT by its ID. We wrap by try catch block and make the API request. We perform a get request to fetch NFT auction details from the backend that includes an authorization header with a value token to authenticate the request. If the request is successful, it opens a model and it also sets the auction state to true. Then the NFT auction data is stored in response.data.data, and end time stores the auction end time from the response. Then we save auction end time in local storage and update component state with NFT data, and in the end, if an error occurs during the API request, it logs the error to the console. After that, we will type the function in the interface and pass it to the provider for further input into components. Then we will type the remaining states function in the context and also pass them to the provider. We also need to typify our state functions into our NFT context type. After that, we go to the OneItem component and extract NFT-related functions and state from the context. Also assign the NFT ID and price to variable and retrieves the auction and time from local storage. After that, we add a check for the presence of an ID in the fetch NFT details function. If the ID exists, we call the function. Then we create a function for placing a bid on the NFT. Handler add bid function is responsible for handling the action of placing a bid on an NFT. If the token is not available, it displays an error notification using toast error. The function then returns early, preventing further execution. Then, if the user is authenticated, it opens the bid model by setting set is open auction. After writing our function, we add onClick handler that checks if an ID is present. If ID exists, it calls the fetchGetNFT auction function to fetch the auction details for the specific NFT. Then we create conditional random of model. The model is rendered only when isOpen model auction is true. The model auction receives several props isOpen that control the model visibly on close that closes the model when triggered, and NFT starting price and end time that passes the NFT data. Then we go to model auction component. First, we write our props isOpen on close NFT starting price and end time. After that, we create interface I model auction, where we define the types for the props expected by the model auction component isOpen on close starting price, NFT, and end time. After that, we use the useAuth to get the authentication token. We create state auction ID that is initialized as null to store the auction ID after creation, and we have a check if is open is false. It returns null and does not render the model. After that, we create auction function that is asynchronous and checks if the user has a token. If not, shows an error toast. Then we send a post request to create the auction with the provided NFT ID, with starting price and end time. We have headers authorization with barrier token. We create variable result in which we add responsible data. If the auction creation is successful, we show a success toast. Then set the auction ID in the state and stores it in local storage and calls on close function to close the model. If there is an error during the API call, it logs the error. In model UI, we add onClick function in which we add in our button. So now you can see that we create variable end time and we add it into local storage. Then we go to our one item page in our code and create variable end time in which we get our auction end time from local storage. So we save our code, go to our website and create auction, and we see that auction was successfully created. In the one item component, we are rendering the model bit component. Conditional based on the state of its open bid auction. First of all, we add onClick function. By doing this, we will click and we click our model open bid auction. The model bid component will only be rendered if its open bid auction is true. This state controls whether the bid model is visible or not. Props passed to model bid is open bid auction, on close, and starting price. After that, we go to our model bid component. We take our props and start to typify it, and we will create an interface. Our interface will be iModel bid props, is open bid auction, on close, and starting price. It will be also our props. Then we create bid amount state that holds the amount that the user enters as their bid. Then call from context token. Balance are obtained from the user info hook, and we have a check if is open bid auction is false. It returns null and doesn't not render the model. After that, we create handle at bid auction function that is responsible for handling the submission of a bid on an auction. It performs validation and makes an API request to place the bid. We ensure that the user is authenticated before they can place a bid, and if the token is missing, it triggers an error message. Then we ensure that the bid amount is greater than the starting price of the auction. If the bid is less than or equal to the starting price, it triggers an error. After that, the auction ID is retrieved from local storage. This is needed to identify the auction on which the bid is being placed. Then we place the bid by sending a post request to the backend server with the auction ID and bid amount. The request is made to the endpoint. The authorization header contains the token, ensuring that the user is authenticated. After the bid is successfully placed, the new bid details are executed. The last bit's bidder information is retrieved and setBidder is called to update the state. The current bid price is stored in local storage along with the last bidder's details. If the bid is successfully placed, it shows a success toast message. And closes the module and updates local storage. If there is an error during the bid submission process, it logs the error to the console and doesn't update the UI with the bid. Then we add onClick function into our image. By click, our model will be closed. And then we add value and onChangeHandler function, which we create now. We create input change handler. This function updates the state bid amount whenever the user types in the bid input field, and it converts the input value to a floating point number. We also display our balance and also add onClick handler add bid option in our button and onClose on cancel. Now we return to the one item page and display the name of the user who placed the bid by performing a check. We retrieve the current user who placed the bid from local storage. Then we save our code and verify it on our website. We can see that everything is displayed correctly. Then I forgot to add the current bid to be displayed. So we retrieve that from the storage as well and verify it in the browser. We successfully display the auction creation, the bid, and the bidder's name on the page. So next we render the model token component in one item page in which we add props is opened by model and onClose function. After that, we redirect in model token component. In this component, we create state variables. The first is amount. This state variable holds the amount to be transferred. The second variable is receiver wallet ID. This state variable holds the wallet ID of the receiver. It is a string and it is also initialized as an empty string. And then we have the structure arising from user info balance and token. We also create interface with it props. For example, is open by model function will be boolean and on close function will be void. And after that we create our states. So now we create a handle change function. It has the change even when the user inputs data in form fields will be changed. The name and value of the input field are extracted from the event.trigger. If the field name is amount, the value is converted to a floating point number. And stored in the amount state using setAmount. If the conversation is defaults to 0, if the name will be receiver valid ID, then we add our value into set receiver valid ID function. Then we create handle at transaction function that is used to initiate the transaction, such as a transfer of funds and handles validation and API communication. If the amount to transfer is greater than the available balance, it shows an error message using toast error. If the token isn't available, it shows an error message indicating that the user isn't authenticated. If validation passes, it sends a POST request to the server passing the amount and receiver valid ID in the request body. It includes the authorization header with the token and the content type as application JSON. So we add amount and receiver valid ID, and we have the header authorization with barrier token. If the response status is 200, It shows a success message using toast success. If any errors are caught in the cache block, they will be logged. If is opened by model is false, it returns null and doesn't render the model, meaning the transaction functionality is hidden when the model is not open. Then we copy our name of function and we add onClick in our button continue, and into our onClick we add our function. Also we add onChange handler and value in our input field. In receiver wallet ID and amount. And onClick into our image. Then we navigate to one item page and define the handler by NFT function, where we have an error if we have no token, and then if everything is good we open by model, else we have an error. After that we attach an onClick event to our button so that we can initiate the transfer using a valid. Then we move to the notification component where we define the iNotification data interface. We retrieve the token from user info context and initialize the state to store notifications. In our iNotification data interface, it will be ID, image, message, and date. Then we create a state data with default value iNotification data interface array. Then we use user effect to fetch notification when the component mounts. If the user doesn't have a token, it shows an error message using toast error and exits the function. If the user has a token, it makes an API request. The request includes an authorization header to authenticate the user. The API response is stored in response. Then we extract valid transfer from API response, and the valid transfer array contains all transfer transactions. If valid transfer exists and contains data, it maps our each transfer, creating an object with ID, image, message, and date. If valid ID transfer is empty or missing, it clears the state with set data empty array. Then we console log if we have an error. Also, we call getNotification inside useEffect function, ensuring that the API request happens only once when the component loads. Then we are going to render our notification. We check if data is empty and it displays a message that notification not available. This ensures that if there are no valid transfer notification, users see a message instead of a blank space. If there are notifications, the code loops through each item using map function, generating a div for each notification. Each notification has displays the transfer message and shows the formatted date and time of the transfer. Now we go to our website and log out from our account. We need to create a new account by entering a new name, password, and email. And then we repeat the process without entering a name. Next, we open the profile component to copy our wallet ID and open the website in another tab. We log out from this session and log back into the previous account to make a transaction. Once logged in, we initiate a wallet transaction by sending tokens to the copied wallet ID. After that, we switch back to the new account and check our notification. We can see that the amount we entered during the transfer is successfully displayed, but we need to adjust the styles to improve text visibility. That's the end of our front-end development. Thank you for all watching. Let me know in the comments what do you think and suggest a new topic or tech stack for the next video. Goodbye.